Oh, okay, we've got sound.
You could always do a Nathan Thompson musical introduction. Beep, 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 beep.
Yeah, we
Yeah, I can
definitely
whistle it
need.
for you.
Yeah, definitely need some sort of music or tune or something for the
You
timer.
do.
Yeah, I'll have to talk to Alan about that. See how I can add that. I've only got one tech support.
I I tell you what I do have is I have this. I think it's an hour-long loop of that Kevin MacLeod music, Monkeys Spinning Monkeys.
Kevin Cloud, the guy that does the restoration of the house thing show, whatever it is.
Not him. He does all this free to use music that's available on YouTube.
Okay.
And there is a piece of music, and quite often, if I'm listening to a debate or I'm listening to the idiots in the Discord server, I'll set that going as well and sort of lower the volume so I can hear it in the background as these idiots are talking. That adds a certain atmosphere to it.
Okay.
But I've got it running now.
Get John Stuck to write you an intro and an outro.
Well, he's already got stuff that he's posted, so I can always pick something out of that. I'll pick one.
Get him to write you something specific for an intro and an outro, and then you can advertise his channel, give him a bit of a boost.
Yeah.
Oh, speaking of advertising for a channel, Timbo Turtle is. We'll see if we can get him up for a couple of subs. We'll do a sub drive for one of the peanuts.
Well, he was very recently up to 3.
Oh.
Because I noticed you became the second one, so I thought, wow, I'm having some of that.
Yeah.
So I've become 3. 3 is the magic number.
Yeah. We'll see if we can get Timbo a few more then for tonight.
Anybody out there who's not familiar with it, I'll put the link in the side chat. This isn't an hour-long loop of monkey spinning monkeys. Just have that playing in the background as you're listening to idiots arguing about the shape of the earth and trying to tell you that all horizontals are parallel to all other horizontals and such like.
So this is royalty-free, whatever they call it.
Yes.
There we go.
I love this bit of music.
Long enough? Oh yeah.
It goes for this one goes for an hour and 2 minutes.
Okay, well I can bite that down to the 4-minute timer just to play.
Well, I think the original's not very long at all, but it just loops and loops and loops. But if you have that playing softly in the background as you listen to the likes of Bev and his numpties, it adds a certain something to it. You know?
It adds atmosphere. Yeah.
Yes. It's quite mesmerising, I think.
Well, I was just going to play the 4 minutes of it from the start just to see what we'd get. Just let it play underneath while we're talking.
I think this got used by the likes of Cool Hard Logic. I think he used this chap's music quite a bit.
Well, anything could do for now, just so I know how to put it into the media source.
See, Earther's Life has got it. Play this over one of Brian Leakey's videos. That's exactly what I do, Beat.
Oh, okay. Okay.
Because, of course, I'm streaming everything through my headset. So, you're listening to a discussion and just sort of set this playing in the background. Just turn the volume down a bit and yeah.
Like I'm doing now.
Yeah, exactly. So you can hear what they're saying, but in the background, because sometimes these people, especially in Jose's, when you get 2 or 3 idiots in there and they're just shouting and they're screaming, you think, I just listen to some music at the same time, you know. And sometimes it's proper music, and then sometimes I'll just boot this up.
Is it okay level where it is now, Peanuts? We're not drowning it, or it's not drowning us. I could use this one. Okay, what's that one?
Well, what's he got there?
I don't know. The Majestic Fanfare ABC Radio News theme. Yeah, but is it royalty free, whatever they call it? Yeah, we'd have to find out if it's royalty free, whatever they call it. It's an audio clip from the original recording made in London for the Queen. Whole light orchestra, Charles. Majestic Fanfare. That's giving you all the stuff about it. Credits. Production company, ABC composer Charles Williams.
Oh, Larry, the music is starting to get very annoying already. You can listen to it for an hour.
It is a little. There really is only so much of that you can take.
Yes.
Oh, well, it's been going for 4 minutes. There you go. That's the 4 minutes of it.
But yeah, that's. Let me put a link to the chap's YouTube channel, because if you scroll through there, you'll think, oh yeah, I've heard this one before. Oh, I've heard that one before. And I think he's basically supplied most of the background music to just about every YouTube video you've ever seen, you know.
Timbo's saying 43, it could be out of copyright.
1943? Yeah, could be.
70 years, isn't it? The thing? I think it's 70.
Let me just, I'm going to have a listen to that.
I have to put those links over into where can we put them?
Blimey, that's
videos, I suppose. Yeah, I'll put them over there.
That is a bit of a fanfare as well. Grief.
I'll just put them over in Tech Doc videos. Paste it over there. Look at the size of the link. And what was that other one we had? The one we just did? That one. Copy, paste. Yeah. Oh, Paul's got A something M. A something M. How many letters? 1, 2, 3, 4, 5. Some free YouTube Aussie music incoming. Oh, I've got to scroll back down.
I suppose you want a clue, do you?
Yeah, that'd be good.
Yeah, we haven't got a clue.
There you go. You have now.
You doing the reading for these now, Farmer, or I can do it?
Yeah, if you want, that's not a problem. There we are.
Yeah.
Today's scientist, the first American to be awarded the Nobel Prize in Physics, became famous for establishing the speed of light as a fundamental constant and other spectroscopic investigations. That sounds like an album title. Spectroscopic investigations.
Yeah.
Matey boy in the new model army. No.
No, not more thousand. No.
Too many letters, isn't it?
Clive Wells has it.
Oh, did Clive get it?
Clive Wells is the winner.
Clive, where are you,
Clive got
Clive?
it. He knows his physicist.
No.
That guy.
So I just that's not the sort of useless
Well
information
done,
I remember.
Albert Mickelson.
Nah.
Yeah. But if you want to know the width of the tank tracks on the Tiger on the Tiger Alps E, then I'm your man. That's the sort of shit I remember.
Metric or imperial?
Metric.
Well, see, that's the sort of useless information I don't remember.
Yeah, well, there you go. Earth is Life. I've been talking to Mr. Sensible about playing music on Mage 3 using an MP3 player and a GoPro with a microphone.
Wow.
Oh, so it actually plays music as it goes up and he records it whilst he's filming it. Now, that's pretty cool. I like that. I like that. Yeah, asked Derpy Dave about spectrophotometry. Isn't that what isn't that what Dr. D claims to have a doctorate in? Something like that. It claims to have a doctorate in something you can't get a doctorate in. It's no good. I need to go make another cup of tea. My throat's dry.
Okay. Our farmers is doing that. Where am I? And Alan's not here tonight, he's playing with the kids. And we don't know where Blue is, or Matt. Oh, that's right, Fight the Flat Earth had Professor Phil on. I'll grab a bit of that, if anyone missed that. Grab that. Who's the other one? Oh yeah, McToon done, MC Toon done Flat Earth Debate. That guy. Just says Drano Pit 1. Whoever that is. Let's all hide behind the couch. Oh, you missed the Toon one. Are you talking about the one I just read? The Drano Pit 1? That's the one. I don't know who that is. Get an image of him. Okay, throw that back there. So I've got Toon, Phil, and I'll go and grab a Lindsay. Lindsay, where are you?
Quick, let's all hide so Farmer's Boy comes back to an empty room. Guess that didn't work.
No, that didn't work too well. So we've got, if you didn't hear me, I said we've got the Phil, the MC Toon one, and a Lindsay.
Yeah, I watched a few minutes of that Professor Phil one, but I think I was just too busy.
Yeah, we'll play bits and pieces of that one. Spoiler alert, Carl. How far back were we? Looks like here, part 2. Ladder design in 30 minutes. Oh, it went in 26 minutes, so that's not 30 minutes. You lied, Lindsay.
Yeah, but if you look at the next one, it's only 9.5 minutes, so...
Okay, well that's what he didn't get to. Well, still 9 and 26 adds up to a bit 36 minutes.
Well, this is Lindsay. You don't expect him to be able to add up properly, do you?
Oh, we'll finish off with the part 3 one.
Yeah.
Put that over there. And probably you've forgotten about everything that he said last episode, so it doesn't make any difference. All set over there. Yeah, 9.5, half of Lindsay used to make you crazy. Yeah, that's right.
Yep.
Oh, who let Farmer's Boy know about the plan, Carl said.
Carl. No point leaving that up there and writing for me, is it?
Do you think Lindsay scripts these streams?
No.
Not working on a script. Because he puts notes down and then he has to read his notes to go where he was up to, what he was thinking.
Yeah, and he struggles to do that.
Yeah. Wait. What? Is he back? I'm still behind the couch. Timbo's still hiding by the couch. Yeah. There we go. What have we got? We've got 9 minutes on Lindsay's speed.
That's not so bad.
Where's Matt to say the P word? Where is he? Where are you,
I'll
Matt?
tell you what. Don't pay him. If he didn't turn up, don't pay him.
Yeah, he's not getting paid. I'll send him a DM. That'll wake him up.
Sure.
I'll say wake up. I'll go wake up, Matt. Plonker. Yeah, but it's not a 4-letter word either, Carl.
Be careful which 4-letter word you choose.
It starts with P.
Yeah, I'll need one of them in a moment. Tell you what, Terry.
Mm.
Can we tear the Band-Aid off?
He said no, I won't. I'll say waiting for the P word. He's around.
Oh, right.
Yes, because he said
Well,
no,
yes,
I
I can
won't.
see he's online.
Yeah, I said wake up, Matt, and he said no, I won't. And I said I'm waiting for the P word. Let's see if he responds to that. Here he's here.
He's going to come in, say it, and then go out again.
You brought him in. You probably just say that and then go again.
Yeah. Terry.
Oh, hi, Matt. How you going?
Terry.
Yes, Matt.
Press play.
Okay.
Welcome everybody, welcome to another video by Flat Earth Philosophy. Everything's flat earth here and it's all based on ancient philosophy, myths, legends, religion, and what I basically discovered myself as a flat earther, wanting to know how it works. Being a flat earther, if I'm going to argue with somebody, I need to know how it works. So I set out on a course to find out how it worked, and I found out how it worked. Then it was all reaffirmed by all the ancient philosophy and Gnostic, esoteric writings I read. Now this is a news flash. Major information. Those who've been following me since day one would have noticed that I had the North Pole and the South Pole the same. No North and South, they are the same poles.
Are they?
You're seeing in my latest videos.
How can they be the same?
At the same time, it'll be spiralling out of the north. And they marry up around midnight here.
So my compass points to north and south at the same time, then, does it?
A straight meridian north to south. Realise the direct route from north
Well, it
across
wouldn't
the
need
top
an
is
arrow
direct.
then, would it?
There's no arcing.
No point in having a compass.
So that is the same as that. And these are what my previous videos are all about, because that's what created the separation of the tropics, the tropical gap. No one understood the tropical gap. I'm the first in the world to bring it up, and it proves the whole flat earth model.
Yeah.
So they're both southern
I wonder why
fields,
that is.
north-north, or you could call it south-south, north-north.
Perhaps you're the only one because it's a load of shit.
But that is the same as that, and these are opposing each other, so they have to be the same poles. So this is how it works. We've got the negative magnetic field coming off the Earth, coming up to the Sun, and we've got a dual field coming up through the gap as the male over feeding the Sun at this top end. So you've got a negative and a positive system, basically. I call that the EMF being created in here, because we have the
What?
EMF
The
and the
EMF?
induction motors. We have the magnetic induction motor gap, don't we? So we call that the EMF, so I'm calling this the EMF. But it's male and female.
What do you say, EMF or EMS?
Philosophy, the Iliad, for example, these are females.
I presume he's talking
Hearing
about
with the
EMF
male.
as an electromagnetic force.
So the male is
Yeah.
coming up here as a helix and gets drawn into here. This is a dual system too, because every positive field coming out, there's a negative coming through underneath. There's always an opposing, the opposite, the counter force. This is what's creating the helix up here. And these are finding pairings. They're pairing. This is the pairing in physics. And that pairing creates the helix, actually. It comes over here and creates life. You know, we've got a DNA, the helix, it's life forming. That's the pairing. So you're not getting the helix down here, not until they find their pairing. Then they go up and create life, because life is the sun. The sun creates life. Check out my earlier videos I've just put out. I've just shown the whole flat earth design, how all this here is back here in creation, exploded out here. So now we know why there's the field here, the separation. They're both the same fields. So it puts a spin on the works with my latest explanations about south being the weak force and a north pole being the strong force. It doesn't work that way now, but it's still got the strong force in the north,
Oh, you should change
the
it.
north, and a weak
Or
force.
maybe
down
it doesn't
here.
work at all.
It's more it's weaker. So you've got a north,
Yeah.
a strong
He's changed his
north,
mind.
Yeah, it's changed, yeah.
It's be a weak north. So this is where the physics get into electrons, muons, bosons, start breaking it all down. So,
Is he conflating this with strong forces and weak forces?
Because it's a weaker force.
I don't
Like,
think. I
as
don't
in
think
the
Then
five
it
fundamental
becomes something
forces.
else, not
yeah, I don't
strong
think he knows what
something
a
else.
force is.
I call them bosons or muons.
That's
or
where he's
whatever, I don't
conflating
know.
it with the five
I'm not a
fundamental
physicist.
forces, isn't he? Two of them.
But I'm a bit more of a thinker than those guys. They think they live on a spinning ball, and they think a magnetic field goes from the bottom of the ball all the way up to the top and doesn't shut the whole system down by finding equilibrium. It's a ball, for goodness sake, you're chopping it 50-50.
What's that
North and
tune
South Pole are
there?
going to find equilibrium,
Do,
and then
do,
sit at rest,
dee,
then there's
do,
no life,
do,
no action, no
do,
life,
dee, do.
no gravity.
What?
It's all found equilibrium like this. This
I
finds
think it might be the
equilibrium
music we're listening to
and
earlier.
creates the black hole up here. But they don't all stay there, they keep flowing, they don't all pair and find the black hole. They'll keep flowing, whether they die or just keep going and recycle, to have another go. It's like life. This is what's going on. So there you have it, everyone. The gap explained. there is the flat Earth model. Obviously, the
Yeah,
same under
maybe it's
here.
the southern north. Yeah.
What misses the sun or the black hole
I'm
carries
glad
up,
it cleared
comes
that
down through the Earth, up here, down again, through the Earth, and then up here. If it misses, starts again. This is the perpetual cycle. The snake, the infinity sign, it's all there. Now we've got the entire model, and it's all been explained. So I'll call this part 3 of the flat Earth design. In 30 minutes. Less than 30 minutes, obviously. What else can I put in here?
Didn't even check the time for it.
So you've got to realise that
That's
it's
it.
the,
Left leg in, left leg out.
everything is all connected. So you've got pressure, high and low pressures.
In, out,
connected
in, out,
with
shake it
hot
all
and
about.
Cold. So we've got the cold out here, we've got the cold here, rushing to the warm, getting pulled down to the warm, and the warm's coming up. It's the counter forces acting against each other to find equilibrium. Now, if all the ice is melting in the north, the way I see it, we're going to be a little bit screwed.
Oh
You have to
no.
have cold here and cold there and warm here for the Earth to run properly. If it gets a lot colder, warmer here, how's this energy going to flow over there? It's going to be very slow. It's going to move very slowly. So we could have a problem. Look how hot it's getting in England these days. 38 degrees today.
Where's the music coming from?
Mounting runways. Yeah, so there could be a problem.
Somebody said to play the music in the
This is all
background.
coming from the negative field of the Earth. Aqueduct.
Farmers is trying to do air
Europe.
guitar to this.
I-
No.
The Earth.
It's air double
in the
bass, dear boy.
Oh, air double bass.
From the
Okay,
I
alright.
can't hear
Arctic
it.
centre. And it's creating this
It's
energy.
rocking.
It's getting pulled up
Yeah,
this
all
way.
right, okay.
Pulled up. And then becomes the helix.
Hey, you're a
It
duck.
makes these videos so
Bring
much
back
more
into the
fun
sun
when you've got
like
that in the
this.
background.
Like
It
I
does
say,
actually, you're right.
Life
Yeah, I can't
creating
control the
helix,
music
creating
separate
the sun.
to the-
Sun creates
to-
Might start
life
headbanging
on
to it in a
Earth.
minute.
There you have it, folks.
I can't mosh with these headphones.
No
They
North
come
and
off.
South Pole. They're both the same. I had this on Facebook for a couple of years before I even got into YouTube and declaring all this. Never got a comment though because it's above everyone's head. There you have it. There you have it. Share it. Share the whole series. 3 videos. Cheers.
Ah,
Share it with who?
That was
yeah.
quick.
I'm not sharing it.
Yeah, well, he didn't quite finish off in the last video, so.
Ah. Oh, we can stop the music.
Yeah, well, they sit on it, but they don't really. I don't like them too tight.
Okay. So did anyone see Phil's debate?
Not really. Like I say, I only watched a few minutes of it, so I've got no idea where you want to go or anything.
No, I got no
I-
idea
I
either.
watched, yeah, I watched a little bit of it, like the first third. And I thought, like, yeah, I
Oh,
might watch
Professor
it.
Bell.
Yeah,
Was it? Phil
yeah,
Bell.
Phil.
that one.
Yeah, Phil.
Yeah, I mean, the other chap, the Flurf. I mean, he seemed very polite.
Yeah.
It wasn't one of these sort of shouting matches, probably because it was Phil Bell he was talking to and not FTFE. I think that's half his problem, but
Yeah, I'll probably just jump in somewhere. I don't think he does any presentations by the look of it. Oh, Craig drops in there. I'll go after that.
but I thought his intro for Professor Phil was quite funny because he said, "Oh, you was involved with getting something to the moon," and then he's talking about how the landing wasn't exactly what you call soft.
That's splat.
Yeah, because of course the poor thing it crashed, didn't it, at high speed?
Yeah.
Yeah, it was
I mean,
more of a-
from all accounts, it was quite a number of months later. They actually found that it was reasonably intact, actually.
Yeah,
But
but
it's too damaged. Yeah.
It wasn't what you would call a controlled
No,
descent,
no,
was
of
it?
course it wasn't. No. But I think people were expected it to literally be in, a million pieces, spreading a crater across the moon, but it wasn't. So what I'm saying is that it wasn't a soft landing, but then again, it wasn't like kaboom, is what I'm trying to say.
It's like
But it was just
probably like dropping a car from 100 feet off a crane, and then you watch it splat on the
yeah,
ground.
maybe,
It makes a mess, but it doesn't rapidly disassemble in all directions. Yeah.
So I mean, there wasn't bits all over the place. It was reasonably intact, but it was just too damaged to do anything at all.
Well, they miscalculated its velocity for the landing, for the gravity. That calculation.
I can't remember.
No, it was I think it was wasn't it? Unless I'm thinking of the Israelis, wasn't it an engine failure, a thruster failure or something?
I think it might have been. Yes. They hadn't done anything wrong. It's just one of those things. Something goes wrong at the last minute, and you've had it.
Yeah, exactly. It just goes to show it's not an easy thing to do.
No.
We don't need to change the playback speed, do we?
I wouldn't have thought so. I don't know. I didn't really watch it, so.
Well, I jumped to about here. We'll see where it feels.
My foot with a certain amount of acceleration in your mass, would I feel a force? The answer is yes. But then I can ask that question in the middle of thin air, in the middle of outer space. So if me and you are in the middle of outer space, devoid of any large objects, no gravity, no nothing working on you, and you came crashing into me, whatever your mass is, times your acceleration, I'm still going to feel that force. So that doesn't make a valid argument for your gravity explanation or why I feel pain when you stepped on my foot. Because if I'm in the middle of outer space and we still apply the same thing, the same math, force equals mass times acceleration, I'm going to feel the same amount of pain that I would feel on Earth. And that's what you're failing to explain to your viewers, that there's a difference between inertial mass and gravitational mass. So second, when we talk about the gravitron that you talked about, that measures all of these things, all right, a gravitron definitely, a gravimeter definitely would make a cause for your rotating globe Earth. Cool, I get that. But I do also understand that every instrument that is made has to be calibrated to do what it does. These instruments don't do what they do on their own. We humans program these things to act how we need them to act. So if we set a basis for that gravimeter, then we know how this gravimeter is going to act in certain situations. And definitely it works. Like I said, it makes an argument for you, but most of us don't have a gravimeter. So if we go outside and we look, it looks to us that like the stars are moving across the sky. It looks to us like
most of us have gravimeters on the phone, don't we?
I'm not saying that we're right.
Yeah, I think we do.
At least you guys can say, hey, I understand why you say that when you look out of your window. I understand, but hey, this is the math to why Polaris never moved in a million years. This is the math to why the constellations are the same as they were 50,000 years ago.
Why do they always get
you should
wrong?
at least be able to understand.
What's that?
Well, they get everything else wrong, so why should they change for that?
Yeah.
Yeah, if you're going to be wrong, at least be consistent.
What's that, Paul? Get what wrong?
Oh, just like, no matter how many times you tell them, I mean, it's been said so many times now that Polaris doesn't actually remain stationary and the constellations don't actually remain constant. It's been said so many times that you'd think they'd stop saying that by now, but nah, they just keep trotting out the same old garbage.
Oh, they think they haven't moved for thousands of years. Yeah.
Oh yeah, I mean you can tell the same fluff over and over and over and over again, and they still keep saying it. The same person, and it doesn't matter how many times you tell them, explain to them, it just goes in one ear and out the other.
And can I just point out that Blue Marble Science has brought a doctor's note?
Oh. Is it signed?
He's out in the side chat.
Is it signed?
He says, I've got a doctor appointment, so need to leave very soon. If I'm back in time, I'll see you at the end. See, he's got a doctor's note. I mean, that's just perfect.
Yeah.
Well, because he's got an appointment, it doesn't necessarily mean he's got a note. So he's got a note. Just don't, let's not assume anything here.
Matt. At some point, we need to have words.
Yeah, definitely.
I know.
Work with me, not against me.
No, why should I? Don't want
to. Yeah, notice that.
Then when a person looks out relative to our reference frame, everything is moving. And it would be impossible for us to tell the difference on if we're moving or if out there is moving if we're in this non-inertial reference frame. We would not be able to see any of this moving. Now, if we were in an inertial reference frame, we would see everything moving, and everything that we would see would be moving in these from the view of the observer. So the apple that falls straight to the ground is going straight to the ground from the view of the apple. From the outside of observer is following a curved path. All right. So, like I said, a lot of things that you say can go both ways. And a lot of times, I think a lot of you guys just don't. You make arguments that's totally obsolete, just like that foot argument or the gravimeter argument.
Why is that argument obsolete?
Because it had nothing to do with gravity.
No,
because you was trying to get me to say that the force that was exerted was gravity when it was not. Because if we are in the middle of outer space where there is no mass around us, there's no gravitational
just going to correct you, Wendell. Just stay for a minute. You said that if you were in you said that if you were in space, which by the way is a very nice thing that you agree exists. So you're a very unusual flat earther, because most of them say space is fake. But given that you agree that space is that takes a lot of the the wind out of my sail, actually, because I was going to argue with you about space being fake, but never mind. But I want to get back to what you said. You said that you would feel your foot would be hurt if I bumped into you in space. If that happened in space, you wouldn't. Okay. The reason your foot is hurt is because you got the ground also resisting underneath that, and that's why your foot hurts. If I just bumped into you, your foot wouldn't hurt. Okay. So.
Can I correct myself? Can I correct myself? My foot wouldn't hurt.
Hang on, I haven't finished. I haven't finished. I've got another.
Wait. One sec, guys. Prof, just let him correct himself if he was spoken wrong, and then we can get back to your response.
Let me correct myself. My foot may not hurt, but I would feel the exact same amount of force. Is what I'm telling you. The force equals mass.
You wouldn't see the same amount of force you did
on
Earth.
So if we are in the middle of outer space,
you just bounce off each other.
The laws of physics don't change. It's never going to change. That your force equals the mass times acceleration. The same amount of force that you hit me with, it's going to be the same amount of force. That's the math that we use.
Yeah, and what's the problem with that?
There's no problem with that. What I'm telling you, what your argument that you made would mislead your viewers into thinking that the force that caused my foot to hurt here on Earth is caused by gravity, and that's what you wanted me to say. You tried to force me into say that.
What do you think? What do you think caused it? Caused me to fall towards your foot, to accelerate towards your foot.
I think that you were following your natural path through space-time, and I stopped you. So if we are, so listen again.
Yeah, I'm not arguing with that. I'm not arguing with that.
One second, guys. Let's not talk over each other. Hold on. Let's not talk over each other. Professor, please respond to what Wendell said there, and then I do have a question from the audience that I think needs to be asked. Right, so, Professor.
Okay, go ahead, Wendell. What do you want to say?
Oh man, I lost my train of thought.
Sorry, right, okay. Let me ask my question, because I think this is relevant to the conversation. A lot of the people in the audience are asking, Wendell, could you describe to us the difference between weight and mass?
Yeah, weight is the force that's created by gravity. Mass cannot be changed. Mass is defined as the amount of matter in an object. So mass never changed. The problem with weight and mass is that weight is inconsistent. It changes depending on the gravitational field. whereas mass is 100% consistent. So if we ask a scientist what are they going to use, or they're going to use to measure something, they're going to use mass. So I mean, like I said, it's not like I have an elementary education. I do understand what mass is. I have a different understanding of why we applied this math and created weight, because in most instances we can use mass and we can get the correct answer. And I know Isaac Newton understand it. And that, to me, that's also a relevant question when I'm debating what is the difference between gravitational mass and inertial mass. You know, to say what is weight versus mass is very, very condescending.
So do you agree, Wendell, that mass is a quantitative measure of a resistance to inertia?
That's what we call, that's what inertial mass is.
Okay. So we're not actually that far away from each other, Wendell, because the only thing that's left really is, because I mean, I see that you've got a reasonable, you know, high school understanding of how this works. Okay, I actually I'm quite impressed, Wendell. So
it's not bad for a flat earther.
I think that you're pretty good.
You guys are awesome, dude.
All right,
sorry.
So I think you're pretty good. and you haven't said something absurd like space is fake. Okay, you realize space is a thing, right? And those objects that are in space, now that we agree that space is fake, is there any reason why you think we can't send a rocket to the moon?
Brother, I'm not going to debate whether there's something like the moon landing. It's just like it's something that's going to be very.
Just sending. Don't worry about the moon landing. Let's just talk.
Well, listen. If it's a common sense question, should require a common sense answer, right? If there's something physically out there that's able to be reached, maybe with the proper technology, you may be able to reach that thing that we're talking about. So I'm not going to deny that there is something. See, something simple, an easy way, if a flat earther say, hey man, those objects out there ain't real, you could easily say, well, the energy that's coming from those damn objects are definitely real because we can capture this energy. We know that the energy is coming from somewhere, right? So to me, that's an argument that's very elementary. We don't need to debate whether outer space is real or not. Now, when we debate whether us humans have been there, and if we are exploring outer space and doing X, Y, Z, that's the argument that we can debate, because I don't know. I'm telling you that in my mind, it would be very, 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 very difficult in order to do this, being that the speeds that everything is moving within the model that we currently use. But hell yeah, there's the moon is out there and the sun is out there and there's stars out there. I see them every night. So there's something that's physical. So anything that we can describe using our five senses, we consider those things to be physical. And if there's physical energy coming from these objects, space is real. So I mean, that's not what we're debating. Yeah, that's not what we're debating, man.
Right. So yeah, we can send a rocket to the moon. So and you can add a few more varies on top of that. Very, very difficult. It is
exactly. Exactly. Right? The questions that I have is more technical. The questions that I have is the surface questions. The questions that I have is very technical. My questions are things like, why is Coulomb's law and Newton's law of gravitation so close to each other? You know, why is it that we haven't found a graviton? Why is it that the force of attraction is only attractive and it doesn't have a repulsive force? Why is it that when people see people floating on the ISS, they say it's cause of gravity? No, they are in free fall, you idiot. They are falling. That's not because there's no gravity and shit starting to float. So I mean, there's two sides of this argument that's totally.
Why are you a flat earther?
What you mean? Because
I mean, just everything you've said is right. So you know, in that sense, I'm not arguing any of that.
Because what I'm trying to get you to realize that from my observation and from my perspective, if I get on an airplane and I fly, that thing is going to fly straight, whether the earth is curved or flat. So from using the equivalence principle, from the view of the observer, well, to me, the equivalence principle is that the situation would be the same, whether you're in outer space or whether you're here. And what I mean by that is that if you're in outer space and you're following a curved line that it would still appear to you as the observer that you're going straight. Am I correct?
Look, you
that's not
keep
the
harping back
principle.
to general relativity. I want you to just focus on stuff that you and I can see. All right. I told you in the beginning. This is a model. You can accept or decline that model, but you can't change the laws. Okay, so let's just leave that the why it happens alone. Now you spoke about the aeroplane. The aeroplane just simply follows the Earth around because the Earth is a sphere, and it has to, because the aeroplane uses the air that's around the Earth in order for it to do what it does. Rockets don't need to do that. Okay, so let me ask you some questions then, because now I don't have to argue that space actually exists. When you look up and you see a constellation like the Starlink constellation, where you've got about 60 odd satellites in a row, right? How do you think those satellites, you said you think the Earth is flat. How do you think they are going around? They travel about 10 times faster than any fighter jet. Okay? How do you picture them going around the Earth? I see them orbiting the Earth because the Earth is a sphere. Okay? How do you see them?
I see them going around the Earth.
So you do have a view of how the Earth looks.
I just thought about that just now when you said it.
What do you think keeps them up there?
What do I think keeps them up there?
Wendell, they fly 10 times faster than any fighter jet. They keep in perfect formation, 10 times faster than any fighter jet. They never need fuel. What do you think keeps them up there? I mean, you're a practical man. You have to be a practical man to be a businessman in a press. Please up there.
Solar power. I don't know the extremities of what's going on.
Solar power.
I don't know. So you do realize that solar power charges batteries and things like that.
Yeah. Okay. All right. So you think that?
But I'm not going to debate you on that.
Some sort of Wendell.
I'm not going to
debate you. No. So Wendell, you think that solar power is going to drive something 10 times faster than any known fighter jet? Why the hell do we have fighter jets that need fuel, that need to be refueled in the air? That we can't fight.
Yeah, just take the fuel out, the fuel out, and put solar panels all over it. Yeah, fine.
Petrol is a good point. Okay, do you understand?
I'm pretty sure there's plenty of reasons.
You understand that to think that these things are going around in a circle is absurd, Wendell.
Okay.
And yet, orbiting a planet explains it perfectly, because, like you said,
nice watching Craig scratch his armpits on live stream.
Explains it perfectly.
Thanks, Craig.
Why isn't your default that one? Why do you have to pick? Why is your default the absurdity that these things could be going around in a circle above the Earth, no fuel, 10 times faster than any than any jet? And actually, I've got another thing going for you. Think about those things that are up there. We can see them, right? So the sun is shining on them. The sun is reflecting on them. It's dark. Where the hell is the sun, Wendell? Why doesn't that bother you?
Why doesn't what bother me?
Why? The sun is gone. It's dark. And yet you can see those things that are reflecting the sunlight.
Because they're closer.
Come on, you're a practical man.
Because relative to my position, they will be closer to the sun. They obviously will be receiving sunlight.
But it's dark.
That's just common sense. It's dark for me. So let me tell you something, Professor. You go to one end of a house, and I go to one end of the house, and you cut your one little light on, or your little lamp in front of you. That's not a valid argument, because that ISS would be closer, or whatever object you're talking about would be closer to the sun. And
I see. The sunlight just stops in the sky somewhere, does it? Right. So there's dark on the surface, but not in the sky. Okay. All right.
Like I said, those
yeah, let's go with that.
Pictures where the clouds above the sun. To me, that's not a basis for the flat Earth of debate.
It's the Fleur magic sun
because if the Earth is a
division
globe, we're going to see the sun
suddenly stop.
The sun is going to appear to be lower than the clouds, when we know that that's not possible. The sun is not in the damn clouds. So there's certain arguments within your model that I totally 100% agree with. I just don't understand the why certain things happen. And I know for me and my observation, everything appears to be flat, motionless, stationary, and that the luminaries in the sky seem to be rotating around
He's
us.
got all this
That's what
understanding
it
of other,
seems like. And it seemed like,
of other
and even some
components
great
of physics,
thinkers,
but not
I can't be too
how the Earth
retarded because
works,
some great thinkers like Aristotle thought that the world was geocentric for some point in his life. And we know he was a genius just like Newton and these other guys. He was a predecessor to these guys, you know?
Really?
So I don't think for a minute that that you know, I think you're quite an intelligent person. Okay, so don't give yourself don't ad hom yourself. Okay,
no,
that's
man,
unnecessary.
we pretty loose.
I think you're intelligent. I just think that you've got some reason that's not based on evidence that you want to believe the Earth is flat. I just want to correct myself. 3,000 over 10, 0.5 is 300. I said 343,600. I think I said it's 343,765 miles. That's how far the sun would be, Wendell, if it was.
You were pretty close with just a bit of mental arithmetic, Phil. Come on. Okay. That's like going, I got 99%, but, you know, I want to get 100.
I have OCD with mathematics, okay? All right, so Wendell, 343,765 miles away is how far the sun would be if it was 3,000 miles up in the sky. Now, Wendell, so I want I've got you to confirm that you actually think the Earth is flat like a circle and things go around it. I know you didn't expect that and that's why I gave you the satellites, okay? All right, because I needed you to, I want you to actually bring in your mind what you think the flat Earth is, and you've done that. Thank you very much. You think the Earth is flat like a circle, and these satellites go around it. So now let's get back to our sun, which you said before what you thought was about 3,000 miles high.
I did not say that. No, you're putting words in my mouth, brother. I told you I did not subscribe to that.
Okay.
You're putting words in my mouth, brother.
Okay. To be fair, Phil, he did say he doesn't give any particular distance for the sun.
All right. Okay. All right. So
I know, and to be even fairer, I know that the sun would have to be further than 3,000 miles away. I think I made myself pretty clear on that as well.
All right. Well, actually,
hell, the moon is supposedly, what, 250,000 miles away? Y'all trying to tell me that the sun is closer than the moon? I mean, come on, man. I just don't want to debate the distance. I think that there's no accurate way to say that, yeah, it's 93 million miles away, even though that the math checks out. Do mathematics. So mathematically, we can say that this is a very, very good theory that this is 93 million miles away, because we've come up with a model that somewhat works, but we know that it does not work in every situation. And that's why you have scientists now trying to think of new models that the situation that works in every situation, whether it's subatomic, or whether it's, you know, billions and trillions of miles away. So there's problems with your model that you guys don't describe, that you're unwilling to talk about.
Certainly not the idea that the Earth is spherical, that model. There's no problems with that. So let's see if we can focus, all right? So 343,765 miles away, that's how far the sun would be when you're looking at it. Now the sun's got us disappeared, hasn't it? Because it gets dark. Would you agree with that?
Definitely.
Okay. So if it's at 0.5 degrees, in other words, the sun is still clear above the horizon, it's 343,765 miles away. Right. How far do you think the sun would have to be so that we don't see it at all?
I did the math, brother.
Well, I'm not even going to try to do the maths on that. Okay, because that would be because I know that it would, even the 993 million miles away would not be enough for me to not see it at all. You see, Wendell,
I disagree. Why because the same logic that you're applying to the sun, we can apply it to stars. We're not going to see these stars at every time. There's going to be the reason why you can't look out in front of you directly ahead, go stand on a mountain and see stars on the horizon, is because atmospheric, refraction, interference, or whatever you want to call it. There's certain things that humans have limitations. And as certain things get distances away, we're going to have more trouble seeing them. Because I can make the same argument to say, well, why is it colder on top of a mountain than at the bottom of the mountain on the equator when the sun is shining directly overhead?
Oh, that's an easy
the
one,
person on the top of the mountain is closer to the sun than the person at the base of the mountain. And all of this is I'm just thinking of off the top of my head because you said
That's
that.
a basic one.
But if a person at the top of the mountain has snow on it, and the bottom of the mountain is 90 to 100 degrees, it's way hotter. So regardless, that person at the top of the mountain is closer to the sun. Why is the bottom of the mountain
Why do you think
hotter?
it is? I'd love you to have if a student said that to me, my response to that student was, I want you to have a bit of a think about that. And let's do that, Wendell. Why do you think that it is colder?
I mean, I've already thought about the logic, I guess.
What did you think
in school and we went through the different layers of you went through the different layers of the atmosphere and so on and so forth, and then you get into this idea that I think is absurd, is that the less molecules that you have, there's not going to be any radiation, nothing to radiate the energy, which makes sense until the point that we enter a molecule into that situation. So the minute I put a molecule in there, the radiation should directly go to that molecule. I seen a guy on Action Labs, man. I don't know if y'all watching, but Action Labs is a great dude for doing experiments, man. And he took a vacuum chamber and he took a laser, put something in the middle of the vacuum chamber. What he was trying to show was that heat radiates, energy radiates even through a vacuum. So even though that thing was sitting in the middle of that vacuum chamber, it still got hot, brother. It still registered the temperature. So if I'm out there in the middle of outer space and I can see and feel the radiation of the sun, it should radiate me in the same manner that laser radiated that little ball, that nickel ball in the middle of the the vacuum chamber.
I'd like to say this, all right? Mm-hmm. You are a million times smarter than most flat earthers I've ever come across. Okay, all right. And so far,
thank you, sir.
And very little that you say is wrong, actually. All right. I think you've got fragments of things that are wrong, but generally speaking, you just would repeat what I would say.
Just thinks the Earth's flat.
Okay? So
sure.
So
coming from you, man, that's a very good blessing. That's a thank you, sir.
Well, you're definitely smarter than the majority of flat earthers who have on the channel, because you can click a Zoom link and join the call, which instantly puts you above the majority of them. So good job.
Most of them struggle with that.
I think this is very entertaining for me, man. I hope
he's even better than that. Look, you've got a pretty good understanding of that, and your description of how of radiated energy is good. Now I need to get back to this flat Earth thing, okay? Because that's the sticking point. All right. Now, we've established you yourself have established that you think the Earth is like a disc, and that the things go around it like that. But you realize that those things would need to have, because you have a pretty good understanding of energy from the certainly heat energy, and you understand that they would need some sort of energy to go around a flat disc like that, wouldn't they?
Definitely, brother.
Okay, so what you're saying to me, Wendell, what you're saying to me is that that these things go around just by themselves. They don't fall. Why don't they fall to the ground? What keeps them up there? What keeps them up there at the speed that they go?
Well, definitely they putting off a shit ton of energy, excuse my French, on their own. If something like the sun, if something like the sun can shine as bright as it does, it definitely packs a wallet when it comes to energy conservation. So potential energy and kinetic energy would definitely be there in the sun to keep itself moving. You know, I understand, you know, perpetual motion ain't real. And let me clarify another thing. I don't know exactly how the Earth looks. Like I said, I know that Antarctica is real. So we're not going to have the debate about the ice wall and this and that. Now, as far as, you know, the whole schematics of, you know, of the Earth, I'm unsure. And I'm reluctant to believe everything that's taught to me. So when I see some discrepancies in some of the models and some of the things that people say and some of the things that teachers are teaching the kids, I say, hey, that ain't cool, man. You know, we got to figure out the right way and let kids know that this subject is still open for debate. Use your mind and you might be smarter than Einstein. But if we restrict our children to learning broken bases, things that we've ourselves have identified of having problems, and not, you know, encouraging our kids to excel through that, then this conversation is dead. Then the future of the world is destroyed. And that's why I don't think that our generations are as smart now as they were back then when people thought the damn Earth was flat. Right now, the IQ seems to be going lower.
No, it's not actually. It's
maybe
the advances in science and technology that's happened in the last 100
individual
or so years.
people are smarter, but as far as the masses, it seems to be dumbed down. Individual people are learning from their predecessors. So
no,
yeah, you know,
my kids know a hell of a lot more than I ever did about various things when I was their age.
Good.
Simply because they have to deal with more. They have to deal with technology that I had no idea about, and I still struggle with it now. Okay, because
I'll tell you what, you got people like people like Isaac Newton, Albert Einstein, Cavendish, you know, Planck. These people were one of a kind people. These people are not born on the earth every day. It takes a certain kind of mind to create these constructs. So
totally agree.
Yeah, so like I said, and this is coming from a time where people believed in ether. So I don't think it's absurd.
They didn't believe the earth was flat for more than 2,000 years.
That's fine. That's fine. But there's people that's 2,000 years ago that's smarter than most of the population today that thought that the earth was flat. And that's my point. And that's what I said.
Do you get?
I mean, you may disagree.
Do you get why? Do you get why? Why, for instance, you know, they didn't have satellites orbiting the Earth. You know, they didn't have any of those sort of things. They didn't have the tools to know and understand at that time. But 2,000 years ago, more than 2,000 years ago, they knew that the Earth was a sphere.
I'm reluctant to believe
why is it? So Wendell, why is it more than 2,000 years ago, plus all of the science in between, plus all of the physics in between, plus your heroes, Einstein and Newton, all of these people, all of these people, Wendell, know the Earth is sphere. Not only that, Wendell, we have satellites orbiting the Earth.
I challenge them.
Wendell, I have a dish on my roof, okay, which was installed by a guy 12 years ago. Now, when for obvious reasons, I was absolutely enthralled in what he was doing. I watched every moment of what he was doing. We talked about the angle at which he would install this satellite dish on my roof so that I could get the television. We spoke about it. He and I had a really long conversation for obvious reasons. That I have not moved that satellite dish at all in those 12 years. Not 1 inch. The satellite up there. How I would be getting the satellite signal.
It's more complicated than what you're talking about. To create the mathematical structure that goes along with it to make this crap work. You understand? So like I said, mathematically, the Earth is a globe. I'm not going to debate you on that. But I'm telling you that from the view of the observer, if I needed to get from America to England, I'm going to go in a straight line. Now, it may be shown as a curve, but just like I explained to you, we're walking towards the globe. Hey, that's a beautiful picture, bro.
Okay, so Well, this is more than a picture, Wendell. This is an actual photograph.
Taken by what?
Have a look at the name of that up there, Chandrayaan-2. This is the rocket.
What's that? It's an Indian satellite.
Yes, this is the rocket. This is taken from a rocket. This is a rocket that took about 43 days to get to the moon, and the Vickers.
How fast was it traveling?
The Vickers rocket, 28,000. Can't remember off the top of my head, but around about 28,000.
So using your math, did this thing take some detours or something on the moon, or is my math off?
No. Let me explain, please, Wendell. You didn't let me finish. So this went in an orbit. So it took 43 days because it didn't just go straight there. It didn't say, "Oh, there's the moon. I'll go right up to it." This thing went around in an orbit, ever increasing orbit. So it started with almost a circular orbit, and then a wider and wider and wider elliptical orbit until finally it reached the moon, and that took 43 days. Okay, before it branched off and then actually orbited. It's still up there, by the way, Wendell. This orbiter is still orbiting the moon as we speak. Okay, now, but Wendell, because I want to get back to flat Earth. This is an actual photograph. An actual photograph of our beautiful planet. Why doesn't this cause you to pause on your default flat Earth?
It does. Anything I see causes me to pause, but I do have the power of discernment. So I don't think that everything I see is actual factual. And I have reason to believe that, the powers that be want to keep people aloof.
Do you think I'm a power that be that would want to?
Definitely. I think you're an intelligent guy who's definitely followed the model and the structure to accomplish what you set out to accomplish.
Wendell, I was at the center when this photograph was taken.
Were you on the rocket when it was taken?
Why would I need to be, Wendell?
Why would you need to be exactly? Why would you need to be at the center?
Wendell, stop. Am I on the camera at the Super Bowl?
Exactly.
Am I at the Super Bowl if I'm watching it from my lounge room? Is it still not?
Same old story, isn't it?
Exactly. That's the point of whether you were at the lab or not. Whether you were at the lab or not doesn't matter about the picture, just like you just said about the Super Bowl. I said what you said and rebuttal to you saying that I was at the lab when it was taken. I'm not denying that they took a picture. I just
never been to Australia, can't exist.
I'm just trying to tell you that no artist made this up, Wendell.
Like he was there. They told it to take the picture, and it took the picture.
This is a beautiful
there
picture.
It was on their screen.
Exactly. That's
pretty gangster, man.
So, I'll tell you something, Wendell. It was kind of rare.
Hold on, one sec. Did you just say to a picture of a rocket that Phil Bell worked on, taking a picture of the Earth? Was your response, "That's pretty gangster, man"?
Yeah, man.
I just wanted to check you.
It is pretty gangster.
That's pretty gangster.
Phil, that's pretty gangster, man. That's the new thing.
Hell yeah, man.
Well, Wendell. So this picture here, it's not like when the rocket is going around, is going in an orbit, that we get a picture like this all the time. Okay, the camera's got to be just in the right place in this orbit for this to happen. Okay, so in other words, it's not that easy. So most of the time, all we see is the blackness of space. And then every now and then the rocket comes in the orbit at just the right angle, so the camera has, and we take a picture like such a beautiful picture like this.
Right, because like I said, the first thing.
Not only that, what country do you think that is? Doesn't that look like Baja, California?
Yeah, I guess the bottom piece.
That really does look like a bit of Mexico in the United States, doesn't it? Yeah.
Yes, it looks like America's penis.
So Wendell, we agreed that at least I don't have to argue with you that space is real. And this
Space
is
is
so
real.
most flat earthers would say, I don't believe this picture because space is fake. I don't have to argue with that with you, and that is just
well. Hopefully, you're not arguing with that with anybody, because that would be the equivalent of arguing with a brick. We can look outside and see things inside outer space, so that's
I've
not
been
an
more
argument
kind.
that we're gonna make. But you know, if somebody was to come to you and say, "Well, how fast was the rocket going? You know, what's the shutter speed on your camera that took the picture and things like that?" Then you would have to explain, because, like I said, things have to be. This argument is technical. This is not an argument for preschoolers. So when I look online and I see people with the preschool, rhetoric going back and forth, I ignore it, man, because there's obviously no hope for teaching a brick. And if you are successful with that, man, brother, I believe anything you tell me.
Yeah. All right. So Wendell,
about 10 minutes, guys, and we're going to get into super chats and questions. Okay.
Yeah. Let's wrap it up, man. Let's wrap it up.
That's all right. So Wendell, I think this is a great one to go out on. So I want you to have this image burn in your mind. I
saw a dope one before from I think it was a Chinese or Japanese satellite. Like I said, I don't know the authenticity of these things. I think it's called the Himawari.
Himawari, yes, that's a Japanese, Japanese satellite.
Yeah, fucking kind of hard to say, but
yeah, that's the one that's the one that we Australia, we use that for our Bureau of Meteorology. So that's our weather satellite that we use over here in Australia. You think the governments in Australia are just total idiots? And there's 10,000 there's Japanese CGI artists just ready waiting to paint this for our government.
Well, where we probably have a strong disagreement at is I really feel like the governments are pushing towards a one world government.
Well, maybe that's true, Wendell. But the point is, they are not They are not a team of Japanese CGI artists painting the world, to fool us Australians and everybody else in the Pacific.
It's a computer generated image. It's a computer generated image, and these guys all get funded from the same sources.
It's a photograph, Wendell. It's a photograph.
Right. I told you I saw a couple of pretty dope photographs from a couple of different satellites, not just this one here. Well, I saw a couple of dope ones, but I still retain my power of discernment to say, is everything being shown to me what it is? Just like I told you with the picture of the black swan. I don't like to debate pictures because sometimes pictures don't tell the whole truth. And that's something that we got to identify. Now, like I said, if everything about this picture is 100% actual and factual, then hey, the Earth is a globe. And long as you can get to see this picture, you have your proof that the Earth.
I'm so clipping that, Wendell.
You're absolutely right.
Flat Earther admits the Earth is a globe. There's a short. I'm releasing that short tomorrow, guys.
I never said that.
Wendell,
Wendell,
I listened to you before, and I had a feeling that you were. I couldn't put, and the reason I wanted to speak to you is because I couldn't believe that based on what you actually do know and your understanding of stuff that's happening around you, and including your pretty good understanding of your heroes. Newton and Einstein, I couldn't believe that you actually did think the Earth was flat, right? And I think that you've sort of summed it up and said that you don't know. Well, Wendell, I'm here to help you a little bit, okay? And you can accept this or not, but you are looking at our beautiful planet. This is an actual photograph. This is no CGI. This is no multiple lenses. None of those things. This is an actual photograph of our beautiful planet, taken from a spacecraft that's on the way to the moon. So I'm going to leave it like that, okay?
All right, and that's a gangster.
We'll leave it there.
So
Gangster.
That's a gangster
definitely
picture.
a gangster.
He doesn't really sound like a flat earther, does he? He doesn't really say much.
But that argument reminds me a bit of the fun and games we had with Mr. Leakey the other day in Jose's hangout. He was absolutely 110% adamant that Himawari images use the blue marble and they overlay all sorts of things to get the images that we see. And no matter how many times I told him, no, it takes photographs every 10 minutes. No, it's all based on the blue marble. Just frustrating to say the least. But yeah, he was very polite, and I think he'd almost got it. Almost.
He's nearly there.
Yeah.
How
Bless.
are we going for time? No, I don't think we've got time to do the tune one.
Oh, is that? Oh, I see. Is that where Brian got it from? Pool on the plane. Oh God. Yeah, they never seem to think up these things themselves, do they? They just see somebody else making some half-assed, ridiculous argument and go, "Oh yeah, I'll run with that."
Yeah, just saying. Yeah, the first flat, and that's it. The planes fly around, and satellites go around in circles. Yeah, that's it. But not all the fundamentals of what it is actually.
Yeah, you'll get Dan the Waterman was saying, "Oh no, satellites can orbit a flat Earth." Yeah, how?
How?
What's the mechanism of something being able to orbit around, over the top of a flat Earth?
Solar powered.
Well, they can't explain it because that's not how orbits work.
Skyhooks.
Ah, yes, skyhooks. The number of times I've suggested that on the site. Well, how are we going to sort that out? Well, you need to put in an order for some skyhooks, don't you?
Yeah.
I'm still trying to invent the skyhook and make myself. I'll become an instant millionaire. Just haven't quite sorted the nitty-gritty details out yet.
Yeah, Matt had to bail. He's got family stuff.
No, it's fair enough.
I dragged him in here for 5 minutes.
Yeah. I honestly thought he was going to go, "Press play, please, Terry," and then just go again. Yeah,
that's what I was waiting for.
Yeah.
Come in here just to say that, because that's what I DM'd
Press play,
you.
Yeah.
Oh, that'll do for that for now.
Would you like a quiz?
Yeah, we've got enough players out in the peanuts.
I was going to say we've got 20 people.
Yeah,
watching.
TT wanted to know, did he miss the quiz?
Got a question for you, farmers. Do you like watching the tennis?
No.
Well,
It's one of many sports I find incredibly dull and boring. Is this a quiz on tennis players? Now, you see, I'd watch tennis.
It says my internet connection is
unstable.
You watch tennis?
I've never seen a tennis game that looked that interesting, I have to admit. I might be obliged. Yeah, I might find myself compelled to watch it a bit more often if it was that sort of.
If she hasn't hit the ball yet. Come on, sir.
Who cares? Who cares? The ball? Really?
All right.
You
quiz. 15 questions.
Look out.
All right. 15 simple multiple choice questions this time. Very simply, what's the difference between weight and mass? Is it A, no difference, they're synonymous? Is it B, mass is the amount of matter in an object, weight is the gravitational force on an object? Or is it C, mass is metric, weight is imperial? Or is it D, mass is a measure of size, weight is a measure of density? Which one? We'll start with an easy one.
I reckon.
Come on then, Terry, it's between me and you.
I reckon it's that one. I might as well just do everyone.
Yeah, that's true. Yeah, because there's let me reset that there.
Yeah, okay. all the peanuts have got it right. Yeah, and this device is actually a device for measuring mass. Okay, so it doesn't rely on a spring scale or a gravitational field. Basically, you measure the oscillation period, and that tells you the mass.
Wow.
Yeah, so it can be used even in space.
I mean, those other three answers, I have heard all of them at some point.
Yeah.
Particularly the metric and imperial. I've heard that used before. And that really is a no. Don't face palm. You're wearing glasses. It hurts.
Yeah. So mass is the actual amount of matter that is contained in an object. Weight is the gravitational force that is pulling on an object. So, of course, the answer was B.
It doesn't help that we use the same unit generally, colloquially, for both.
Yeah, I know. It doesn't.
I think that's what confuses a lot of people.
Yeah.
Fondle said, did you want the flat earth answer? What's the flat earth answer, Fondle?
Well, A, C, or D generally.
All right, question 2. The laws of physics tell us that energy is what? Conserved, concerned, constant, contained.
Not concerned.
Well, fairly certain it's that one.
Laws of physics tell us that energy is A. Oh, sorry.
No, that's all right. Most of the peanuts have got it right. Yes, energy is conserved.
Conserved, yeah.
What's it concerned about?
The law of conservation of energy states that energy goes from one form to another, say potential energy into kinetic energy, and never actually goes away. It can't be created from nothing, and it can't be destroyed. It's not quite true that energy is always conserved. On very, very short time scales, it can be not conserved, as long as those time scales are only very, very short. Okay. Question 3. Which two elementary particles are described as massless? Is it the photon and the gluon, the muon and the neutrino, the electron and proton, or none of the above?
Massless.
Shit, where's my window gone?
Having no mass.
Yeah, no mass. I'm thinking that one.
I'm not 100%, but I'd go with that one.
I'm going with that one. I'm not sure what the other one is.
We've got a variety of answers out.
Oh, that's good. That's good. That's what I like to see.
Yeah. All right.
Where's that fucking note?
Are you going for the same one I did, Matt, or not?
There's a diagram of the ones that are massless. It is the two known massless particles of the photon, carrier of electromagnetism, and the gluon, carrier of the strong force.
Yeah, the gluon is
was
what
long
I wasn't
thought
sure
of. Yeah. So it was actually thought at one stage that neutrinos were massless, but not now. They've actually measured the mass of neutrinos. It's very, very small, but they do actually have mass. Yeah.
Yeah, I've seen photon and I went, yeah. But the gluon would.
Yep.
I have to learn what that one is.
Yeah. The electron and the proton certainly have mass. I mean, that's mostly what you're made of, so they have to have mass, yeah. All right, question 4. The Large Hadron Collider at CERN uses 1.3 terawatt hours of electricity annually. That's equivalent to, is it the amount needed to... Oh dear, I've got some sort of thing in the way here. How can I get rid of that?
No, we can see it.
Oh, good. I can't read that because I've got some green and red.
The amount needed to power roughly 300,000 middle-class homes.
Yeah, okay. Or the energy released by roughly 1.4 million 100-watt light bulbs in a year. Or C, roughly the same annual usage as Madagascar. D, all of the above. Or E, A and C.
Okay. I'm not sure.
Oh, 1.3 terawatt hours. That's a fucking lot. That's a lot.
It is, isn't it?
That's a hell of an amount.
ACDC.
I'll go with that one.
My gut says that one, but I don't know.
I'm going for that one.
All right. The correct answer is, in fact, D.
Oh.
Yeah. A terawatt is equal to 1 trillion watts. A watt is a unit of power equivalent to 1 joule per second used to quantify the rate of energy transfer. In other words, a terawatt light bulb would be really, really, really bright.
Really. I think I need some more reallys on it, to be honest.
It would
Don't look at this.
I don't think you would, want to.
Yeah.
Yeah.
You got D out there.
Wow.
Okay.
TT.
Yeah. Question 5.
You got it.
The universe is made up of 3 main ingredients: ordinary matter, e.g. stars, planets and people, dark matter and dark energy. In what proportions? How well do you know your universe? Is it mostly matter, 80% ordinary matter, 14% dark matter and 6% dark energy? Or is it a good mix, 33% ordinary matter, 28% dark matter and 39% dark energy? Or is it C, a dark stew? 5% ordinary matter, 27% dark matter and 68% dark energy? Or is it D, potluck? We don't actually know.
The universe, it's big.
Yeah,
it's really big.
And there's a lot of empty space.
I mean, you might think it's a long way to go down to the shops at the corner at the end of the road.
So it's got if I'm thinking it's got a lot of empty space, does that help me with any of the answers?
My gut says D. I don't think we actually know. There's an awful lot of guesswork going on.
Well, that's an answer that I'm thinking out loud to myself. I don't know, so I'll go for that one too.
Well, the current answer that we seem to have settled on in science is actually C. All the stars, planets and galaxies that can be seen today make up just 5% of the universe. The other 95% is made of stuff astronomers can't detect and don't really understand, but they know it's there. Well, they think it's there. Dark energy, the repulsive force behind the expansion of the universe, is thought to contribute 68% of all the mass and energy in the universe. Another 27% is dark matter.
So me thinking that space is a lot of it's empty. I should have went down that road. In
question 6.
In comparison to mass.
Yeah. Question 6. Which of these phenomena inspired Albert Einstein in his development of general relativity? So was it seeing an apple drop from a tree? Right. Was it watching 2 trains move in opposite directions? Or was it the vibration of strings on a violin? Or was it seeing a man fall off a roof?
You want it to be D, don't you? Oh, look. That poor sod's just fallen off the roof. I've had an idea. Yeah. I think it's probably that one. But
I'm going to go for that one.
I think we know who the apocryphal tale of the apple tree is linked to.
Timbo Turtle says D rings a bell, only if the man falls on a bell. All right, and the answer is...
It isn't, is it?
Yeah, the answer is when Einstein was interviewed about his theory of general relativity not long after he was published, he said part of the inspiration came from a neighbourhood mishap. He saw a man fall from a nearby roof, thankfully landing in a pile of soft rubbish. The man said he did not feel the pull of the earth while falling, leading Einstein to reconsider Newtonian gravity.
Wow.
Yeah.
Huh. Well, I suppose he was in free fall, wasn't he?
Yeah, for a moment.
Yeah.
Yeah. Huh. All right. Okay. Question 7. When you map out the universe from the smallest size, the Planck length, which is 1.6 times 10 to the power of negative 35 metres, to the largest, the observable universe, which is 91 billion light years across, what do you find in the middle of this scale?
Huh.
Oh.
So what sized objects do you find roughly in between those two extremes? Is it an electron? Is it life as we know it, cells, molecules and the like? Is it the Earth or our solar system?
Blimey.
No idea?
Total stab in the dark.
Yeah, I don't know what
Couldn't tell you.
darkness. I don't know what darkness stab for this one.
Okay. The answer is... It might seem crazy, but the living cells inside a human body and other plants and animals are smack dab in the middle between the smallest and largest things we know. Yeah. Whether that's serendipity or a requirement for life, we don't yet know.
Oh, is that what you meant by the question? Yeah, I should have read it better.
Yeah. All right. Question 8. The largest known star in the galaxy is UY Scuti in the Scutum constellation. If it was plopped into the centre of our solar system, where our sun is, how much space would it take up? Would it be 5 times larger than our sun and 400 times hotter? Would it swallow up Earth and all the planets closer to the sun? Or would its outer edge sit somewhere between Mars and Jupiter? Or would its outer edge be beyond the orbit of Jupiter, basically half the size of our whole solar system?
Oh, I've seen these sort of things before.
Yeah.
It does make our sun look pitiful.
I'd say that one. I'll try that.
Okay.
Oh, it's a toss-up between that one and the other one.
So there's the two in comparison.
Where's our sun?
Yes, it's that tiny little dot in there.
Ah, okay.
Yeah. So essentially, while UY Scuti's mass is only 30 times that of the Sun, it is physically huge. Its radius is more than 1,700 times greater than our Sun's. It was first catalogued in 1860, but it wasn't until 2012 that astronomers using the Very Large Telescope, VLT, in the Atacama Desert finally determined its whopping size. In some diagrams, our Sun is just a single orange pixel next to the colossal UY Scuti, and that's what you see in that image. Yeah. So the correct answer is, in fact, D.
Aha. Wow. Out beyond the orbit of Jupiter.
Do you get the feelings that astronomers aren't very good at naming things?
No.
The Very Large Telescope. Because the one prior to that was the Large Telescope. What do we call this, guys? Well, bigger than the large. Okay, it's very large.
It's very large.
And you know the one that comes after the VLT is the ELT.
What, extra large?
The Extremely Large
Oh,
Telescope.
extremely.
And then the one that comes after that is the FO.
The FOLT.
It's the FO telescope. It's the fuck off telescope. It's that big. It's fuck off.
Yeah. Oh dear. All right, question 9. Speaking of our galaxy, there's a black hole at the middle of the Milky Way called Sagittarius A star. Roughly how massive is it compared to our Sun? Is it about 4,000 times the mass of our Sun? Is it 400,000 times the mass of our Sun? Or 4 million times the mass of our Sun? Or they're radically different sizes but the same mass? I think there's one answer there that you can eliminate right off the bat.
Yeah, how do you have a mass of a black hole?
Oh, this is the one that's called the Great Attractor, isn't it?
No, the Great
Is that,
Attractor
or is that something
different.
else?
That's something else, yeah.
Oh, I don't look.
That's even bigger.
Bigger.
Because the great attractor is attracting the Milky Way.
Oh, that's right.
And other things. And the local group to it.
I don't know.
Okay, the 4,000 or 4 million.
That's an image of stars that they've seen orbiting around the black hole in the centre of the Milky Way. I love the one that just whips around.
Yeah.
Yeah.
One looks like it bounces off it and goes back out again.
Yeah. One obviously goes fairly close into it and just whips around.
Yeah.
And the correct answer is, in fact, C. Sagittarius A star is believed to be a supermassive black hole with a mass equal to more than 4 million of our suns. At 26,000 light years from the Earth, it has never been directly... Well, it has now. Yeah, but that is likely to soon change thanks to the powerful Event Horizon Telescope. Yeah, so it has been seen now.
Yeah.
Yeah. Question 10. Planets come in a variety of sizes. The exoplanet Draugr, aka PSRB 1257 plus 12A.
Catchy. Very catchy.
Like, you're like, yeah, really?
I'll call it.
Is that the best you could come up with?
I think I can call that planet Draugr. I think it'd be easier.
Yeah. Obviously, there's some sort of naming convention that they've followed there.
I guess, yeah.
Yeah. Is the smallest legitimate exoplanet known so far? How puny is it? Is it the size of South Dakota? Is it twice as massive as our moon? Is it 1/100,000,000th the mass of Earth? Or is it self-conscious about its weight and won't divulge?
They're currently doing either a competition or something, each country or something, that they're going to name planets or stars or something, and just give them actual names, which will be a lot easier in the future.
Well, a lot of the stars we can see actually have names.
Oh, this is because of the James Webb, I reckon.
Yeah. So the answer is, in fact, Draugr is roughly twice as massive as our moon. It's in the Virgo constellation, about 2,300 light years from here, orbiting a pulsar in a dead stellar system. So about twice the size of our moon.
Yeah, because there's a certain minimum size, really, isn't there, to get what you would term as a planet.
Yeah, like Pluto.
Well, I think that's more to do with clearing its orbit, is why they declared it's not a planet. But if it's not big enough, then you end up with like the two moons of Mars, Phobos and Deimos. There's not enough mass there to achieve sphericity, as it were. You know, you need a minimum amount of mass to actually get.
You need to exceed what they call the potato radius.
That's it. Mainly because it's certainly one of those, and I can't remember if it's Phobos or Deimos, does have a particular potatoey shape to it.
It does, yeah.
And if it's
I can't remember which of the two it is.
And if it's a potato shape and it's not orbiting, it's called a
potato.
Potato.
A meteor.
Yeah, possibly. Oh.
Which of the following is not a form of energy? Is it light, friction, heat, or sound?
Form energy. Okay, that's a tricky one, this one.
Oh dear.
What's the
I
peanuts
have to have some
thing?
nuts.
Yeah, Timo Sertle says good, an easy one.
Oh, thanks, Timbo. I need a
Most
clue.
of these are
for this
pretty
'cause it's
easy,
tricky.
actually.
This one I'd have to work it through. So that's the answers in the clue of the GIF that you got there.
Have you ever seen this kind of welding?
Yeah, friction
Yeah.
welding. Yeah, on the lathe. Yeah.
Hmm. Does that give you a clue as to which is the answer?
Okay then.
Why do they use friction welding like that, Terry?
Why?
Yeah.
Because it bonds the whole surface area of the
Yeah,
two
that's
components
right.
together.
Yeah. All right. Friction is a force, a push or a
Okay.
pull, or a twist or a squeeze. All right. That can cause a mass to accelerate. A force is a way of transferring energy from one object to another or one state to another. In the case of friction, kinetic energy, the energy of motion, is transferred to molecules when two surfaces rub together, causing them to heat up. So light, heat and sound are all forms of energy, but friction is not. It's actually a force.
Yeah. You know, I was thinking of that one before I was working through it, but I wasn't sure.
Question 12. According to special relativity, when an observer at rest looks at a spaceship moving very quickly towards her, what does she see? Is the ship appears shorter and the clock is ticking more slowly? Or is it the ship appears longer and the ship's clock is ticking faster? Or is it there's no difference in either length or time? Or D, it is impossible to ever measure length or time for a moving object? Which one?
You can't
Yeah.
tell if it appears shorter or longer because you're looking at it directly. You wouldn't be able to tell if it appears longer or shorter if it's flying at you.
The clock's on the ship, Timbo.
Where's the clock? Okay, so you're not thinking of the perspective of the person viewing it directly at you. Okay. That's
So hopefully those two diagrams give you a clue.
Yeah, but that's confusing for
correct
the
answer.
question because you're saying the ship's coming towards you.
Yeah. Special relativity has some seemingly bizarre consequences that stem from two principles. First, the speed of light is constant in a vacuum, and second, the laws of physics are the same in all non-accelerating reference frames. These effects aren't just theoretical, though. They've been verified experimentally. In fact, without taking time dilation from special and general relativity into account, the GPS systems would lose accuracy more than 10 kilometres a day, and you'd be hopelessly lost. Yeah.
So where's the answer?
So the correct answer is A. A.
Okay.
Length compression, things become shorter, and time dilation, time runs more slowly.
I blame the question for that one.
All right, question 13. On a cosmological scale, the concept of distance is actually pretty tricky to define. Why is this? Is it because the Heisenberg uncertainty principle that we can't know exactly where anything is? Or is it because supermassive black holes in galaxies are eating matter too quickly? Or is it because the universe is expanding and the rate of expansion has changed over time? Or is it because we don't have a long enough ruler to reach distant stars?
Well, there you go. It's the ruler.
It's D. D.
Yeah, we don't have a big enough ruler. Sorry.
D.
Just put your finger there and I'll start again.
What do the peanuts think of this one?
I'm going with...
I like the Heisenberg one. The uncertainty principle says that we can't really know exactly where anything is.
Do you know how fast you were going, sir? I'm going to throw Heisenberg back at you.
I'll try that one, Paul. See where I get. Where is it? Yeah.
Yeah, you could try that one, Farmer's Boy. When the cop pulls you over, you could say exactly where did you measure my speed? And if the cop says right here, you say, well, if that's the exact spot, then you can't know how fast I was going. All right. The answer is, in fact, C.
Yay!
The expansion of the universe means that space-time itself is stretching as time goes on. That, coupled with the fact that light takes time to travel to us, can make distance tough to define. If you want to know how far away a galaxy is, do you mean when the light was first emitted, or how far away it is once the light reaches you? Astronomers have come up with several different ways to talk about distance to make sure they're all on the same page.
Okay.
Yeah, if you're looking at something whose light has taken light years to get here,
Yeah.
and then you say, "Okay, how far away is it?" Well, when?
Exactly.
Yeah, when?
Yeah, because in the time that it's taken for that light to get to you, the universe has expanded and the object has also moved.
Exactly.
Yeah. Okay, and another one about the expansion of the universe here. The universe is expanding, but the galaxy, solar system, Earth, humans, and the like are not. Why is that?
What?
Yeah. These things are still expanding, but it's harder to notice because of the smaller scale. Or is it B? It definitely has something to do with aliens. Or is it C? On these scales, gravity and the strong nuclear force are stronger than the expansion. Or is it D? The presence of a mysterious dark gluing force keeps these things together.
I'm going to guess that one again.
Well, yeah, I don't know. I'm going to buck the trend.
I'm thinking that. Oh, you're thinking that one.
Well, obviously it's
Yeah.
aliens, but you know.
Yeah. Who said B? Anyone say B?
It's the aliens.
All right. The correct answer is, in fact, C.
Yay.
Although the universe is expanding on large scales, things like atoms, planets, and even galaxies stay about the same size because the forces that keep them together, the strong nuclear force for atoms, gravity for galaxies, are strong enough to overcome the expansion.
Yeah, that's what I was thinking.
So pretty much the universe is only expanding between the clumps of matter. Yeah.
Well, that's where I always tell flurfers when they say ask what space is, and I said, well, it's the void in between matter. And then if the universe is expanding, well, it's the void in between matter. It's getting bigger, not the matter.
Yeah.
Or smaller.
And the last question. If energy cannot be created or destroyed, why do stars shine? Is it because stars are the only exception to the law of conservation of energy? Or is it because stars burn just like logs on a fire? Or is it because C, this is an active area of research in astrophysics and answers should be coming soon? Or is it D, nuclear fusion transforms mass into energy? E equals mc squared.
Oh, it's not E equals M over C squared.
Not M over C squared, no.
Yeah, M over C squared.
Yeah.
Oh, man.
Why shine?
I really should look at the right bloody screen. People keep sending me emails.
Well, I'm thinking it's light, not just why stars shine. Why do we see the light from the star?
You going to give an answer, Terry?
Bon Scott still shines. Oh yes.
I'd like to give an answer, but So
the
you're
answer
you're
is
saying
D.
that one. Okay.
Yeah, D. Energy and mass are two sides of the same coin, so energy in this case includes the energy bound up in the mass of the atoms. When the atoms are fused together, the resulting atom is a bit less massive than you'd expect. The missing mass is converted into energy, which you get to soak up on the beach.
Okay.
Yeah. The correct answer was D.
D.
Duh.
Yeah, duh. And that was your quiz.
That was.
Oh, thank you very much.
I like that one,
you
Paul.
go.
That was a good one.
Yeah, that was good.
That was good.
There you go.
There was more chance of me answering a lot of those questions than the usual
And
quizzes.
the biggest bonus was it wasn't about bloody tennis.
You've forgotten about tennis already.
Tennis, cricket, football,
Soccer.
athletics.
Soccer.
Yeah, that's it.
Golf.
Oh, golf. Turn them all into motocross circuits.
Oh, dear.
Just give me a 250 crosser for the afternoon. I can do it for you. Map, 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 map.
You missed one.
Golf.
What did you miss, Carl? There's a big blue out there. I can't read the answers on the phone, but I'll give it a try. I've got blue marble science, and now we've got a big blue. You subbed Big Blue? You can get your spanner. Can't have anyone naked out there.
No.
What's wrong, Carl?
Golf would
The
be more
quiz.
exciting if the ball for each hole exploded after 5 minutes. So they would only have 5 minutes to do each hole, right?
Yeah, quick, hurry up. Come on.
Yeah.
No, I mean, I have occasionally watched some golf and thought, how the bloody hell did he do that? But no. You won't catch me walking around 18 holes of a golf course or even 9 holes of a golf course. I mean, let's just go straight to the 19th and have a pint.
Oh, sorry, Carl. Blue must be on his phone. He's sitting there waiting for the doctor.
Ah, so it is blue then.
Yeah, but he's on his phone.
Not
Because,
some.
of course, when you go for a doctor's appointment, you know that the appointment time is not actually when you see the doctor.
Oh yeah, I know. I hate that. I go into
You gotta be
when I ask
kidding.
them at the reception to say, "Oh, how many before me?" and they go, "Oh, about 2." Look, you
Well,
never-
I find if I'm, I can't remember the last time I actually saw my doctor because I tend to see my diabetes nurse more than anything else. But my last trip to Guy's Hospital was that bad that I actually went onto their website when I got home and complained. And 2 or 3 weeks later, one of the doctors phoned up and we had quite a chat about it. Because I said, how can your clinic have been open an hour and you're already an hour and a half late?
How do you work that one out?
That took some doing, and I was sitting there and watching people come in and be seen and go out again before I was, knowing full well that their appointment was after me, and was not a happy bunny because usually I get one of the first appointments of the morning, and they generally see about half a dozen people at the same time, because they've got umpteen doctors and nurses and appointment rooms and all that. But yeah. Not this time round. I was left there waiting and waiting and waiting. And he said, "Oh, can I send you down to a different floor to have a scan of your, a scan of me liver?" And I said, "No, I have to get my arse over to Colchester because I'm due on site to do an inspection." And it took him about 10 minutes to make it clear to him that no, when I was done here, I was buggering off to Colchester. I hadn't got time to play his silly games, especially as he kept me waiting so long. And of course, that was the morning that some poor sod decided to end it all by throwing himself onto in front of a tube train. It was one of those days.
Which picture's the best one.
We had a girl here go to the doctor, and she had a problem, and she talked about it with the doctor. And when that was resolved, she brought up another issue, and the doctor had the nerve to tell her, "No, you have to make another appointment to talk about that." Right?
You're joking.
She was really pissed off, right?
Bloody right.
So this is what she did. She's a checkout chick at the local supermarket. And when the doctor came through with his groceries, she scanned the first item and said, "Sorry, you'll have to come back tomorrow. I only put one item through in a day."
Oh.
Oh, that's absolutely brilliant. Ah,
Yeah.
you've got the photo I took of my latest.
I'm just trying to get the right.
Like I say, it's not. I mean, I don't just do tanks; I do aircraft too.
Yeah.
But I generally do German. But I just saw that and thought, I fancy making one of them.
I think it's coming out all right out there.
A Westland. Why they put it up on the box as British? Yes, it's a Westland Wyvern.
There we go.
I think it first flew in 1946. It's a turboprop fighter. I think those particular markings is the Suez Canal.
Do they counter rotating props or not?
Yes. They
so
counter rotate.
So the torque of the propellers wouldn't affect the pitch of the.
Correct. So counter rotating, they sort of cancel each other out.
Yeah.
And that particular engine that was fitted, not only was it turning the propellers, providing thrust, but the exhaust coming out the back, there was enough of that provided thrust as well, because it's a jet engine driving propellers, basically.
Wow.
And I just thought, yeah, that's a weird looking bit of kit. I wouldn't mind making one of them. So,
at
some point,
what decade did they come out in?
It's the 50s. I think it first flew in 1946, but they were really used in the 50s in the British Fleet Air Arm, as it was known.
Did they see service? Like,
yes.
Okay.
Yes, they used them when there was fighting over the Suez Canal. I think they were used then. I think they might have been used in Korea, possibly.
And mainly a bomber?
Fighter.
More of a fighter.
Yeah, it's a fighter, but what we now call sort of multi-role. Use it as a fighter, ground attack, sort of strike aircraft.
Mm-hmm. And single seater, I can see there.
Yeah, they didn't use it for that many years.
Unusual shaped fuselage with the cockpit right in the top bit. Well, that's to allow for the jet engine to fit in the fuselage. Yeah.
Yeah, because what you can't see in that particular angle, there are two dirty grey pit exhausts in the side of the fuselage behind the cockpit, because obviously there's a jet engine in there. But yeah, they were sort of it's the last sort of the last attempt at using propellers, because jet aircraft were coming into their own and sort of replaced all this.
Okay.
But yeah, somebody I follow on Twitter had been putting up lots of pictures and photos of it, and I thought, yeah, why not? Make a change to the sort of stuff I usually do.
I can see it sitting on the table, but there's no reference to how big the pieces of the plane is for the scale.
We can cure that.
How can we compare the reference to the size?
So there's the box. That makes it look quite large, doesn't it?
Wait a minute, I'll make you bigger. I'll make you bigger. There we go.
Am I embiggened?
Yeah, you're bigger now.
So there's the box. Let's find the main. So there we go. That gives you an idea of how big this is. This is one in 70 seconds. So it's of a size.
Have you got a tank the same scale? Or not the same scale?
Yes, hang on.
Because you know what I'm thinking. I'd like to see a diorama.
So that's the fuselage of the aircraft, and to the same scale.
And there's a tank. Oh, okay.
There's the tank, the 172nd tank I'm working on.
Yeah.
So, yeah, you can see this is getting the aircraft were getting bigger.
Yeah. We'll have a diorama of that aircraft flying above it to bomb the tank.
Not that one.
No.
Stewie, how much was it? That's a very good point. I can't remember.
Carl said new video. What new video, Carl? What do you got? I'll have a look for you, Carl.
Let me see how much.
Any
it was,
other
'cause
recommendations for the peanuts out there that I don't mind? Where are we? Oh, Wally. Wally dropped it.
Did he?
Yeah, he dropped one. Oh, better rewind it. Pause. Okay, I'll put that away. Thank you, Carl. I didn't even notice that yet over in Should You Shit. Oh, there it is there. See? I would have noticed it straight away. How
much did I bloody pay for this?
Oh, Anton Petrov. But what exactly is mass and how is it formed? The answers may surprise you. Oh, dun.
Oh, Stewie, £26.
Okay, I'll grab that. Yeah, that's two long ones. We got a short one? Oh, that's a short one. I've got two long ones and a short one. What else is it?
2 flats, 2 points, and a packet of gravel, please.
Oh, you went on blues this morning, so I don't know if there was much derp on that.
I was quite happily sat downstairs binging something on Netflix, I think, and I saw it gone live after a while, and then I saw who was in there, and I thought, no, no, thank you.
Yeah, I got there at the tail end, like I normally do.
Just one character in particular, I thought, no, I'll carry on watching telly, thank you.
Oh, you and Paul can take over for a couple of minutes while I just go and do something. Well, I've got to step away from here. It's something I can't do here. I've got to go there.
You mean you're going for a pee?
I was just going to say I was going to make.
just go do it. Oh dear. A model of a 109 for 98 quid. That's not the old Airfix 124 scale, is it?
You can make yourself bigger, Farmer, if you want to show anything.
No, you're right. I mean, we've shown the model off. I did give a quick flash of the book I've bought on an aircraft. That's not usually my sort of thing, but I just fancy making the model of it. I don't generally make models of things unless I've got some reference material first. Although I've got absolutely nothing on the Wyvern because, like I say, it's just not my usual cup of tea, but I just sort of sod it, fancy making it. Are there any wyverns still flying? That's a very good question. I would be surprised. No, there's only one wyvern left that's in the Fleet Air Arm Museum in Yeovilton. And I don't think it's airworthy. I mean, they didn't build that many in the first place because it was only in operation for about 5 years. In fact, I think a lot of the old Fleet Air Arm stuff, if there are examples left, they don't fly.
That's why I like those museums that restore certain aircraft to get them to fly again, like what we've got down here.
Well, I mean, I'd say probably the finest example of that over here is the Imperial War Museum at Duxford.
And they fly, and they've got a few relics that are flying around.
Well, I'm not quite sure what the name of the company is now, and I'm sure they're still there. One of the hangars there was taken over by the old flying machine company, and they used to restore to full airworthy condition all sorts of bits of kit. Because when I was there as a volunteer restorator, anything we worked on wasn't airworthy, because obviously you can't just let anybody work on what's going to fly. You have to be a fully, experienced and qualified. Yeah. I mean, basically, what we were doing was getting rid of rust and rot and grot, repainting things and putting them back together,
or whatever it is they call it.
Yes, because an awful lot. Because obviously, certainly back then, before they built the huge new hangar they've got near the M11, there's an awful lot of stuff had just been sat outside for years. That's why they built the building that houses the B-52 bomber, because that had been sat there for years and that was rotting away inside. And they said, if we don't get it under cover soon, this thing's going to break in two.
Do they still have it rotating, like the engine or the propeller or whatever, stuff like that? If it's not going to fly, it still has to be some sort of functionality to them, I suppose.
Well, no, there are a few aircraft over here that are rated for doing taxiing. I think the last Vulcan that we'd got over here, it used to do taxi runs, but it wasn't rated airworthy. So it could get to the end, it could get to the runway and fire its engines up and go roaring down the runway, and that'd be it.
Isn't that to do with the stress fractures that it could have in the internal components of the frame and the wings? Because it would, if you tried to fly them, they might not fly.
Yeah. It's exactly that, which is why it makes it even more impressive that the B-52 bombers that the US Air Force are using now, the last of them were built in the 70s, I think. And they just keep inspecting them, upgrading them, putting new engines in them, inspecting. And I think they're planning on using them for another 20 or 30 years yet. That's like the Battle of Britain Memorial Fund with the Lancaster that they've got. That gets, inspected and stripped down and redone every now and then because it's getting old. Here's another example. The Tank Museum at Bovington used to have a fully functional, genuine World War One Mark IV tank. The old lozenge-shaped thing with the gun sticking out each side. And that dated from something like 1917. And it was only a few years ago that they stopped driving it because they said all of the metal work, all of the metal in it is crystallizing and it's getting very, very weak. And they said at any moment we could take it out for a drive and it will just start falling apart. And that's why they stopped. It still works, but they just don't actually drive it about anymore. So it's sat in one of their displays. Because all of the metal's getting very, very weak and could just come apart on them. There is something's just flying past. I wonder what they are.
Plane.
Well, yeah, but there's two of them in formation. Let me have a quick look on the website. Oh, a pair of Strike Masters. Wow. I wonder where they've come from. That's unusual.
I know some shapes of planes, but I don't know I don't think I've heard of that one.
Oh, we had yesterday. Oh God, bloody thing woke me up. Airbus have built a replacement for the Hercules cargo plane. It's called the A400. It's got 4 dirty great big turboprop computer rotating engines on it. And one came over yesterday, and I think he was well below the 500-foot minimum altitude. Bugger woke me up. Because I'm like, what the bloody hell was that? You know.
Well, could you feel the thump of the engines as it went over? Propellers.
But just yeah, you just and of course, yeah, I wasn't looking out the window at the time, so I heard it go over, and of course, by the time I looked out the window, it had gone.
Yeah.
But I had to look on the website that tells you live what's flying in the area, like I did just now for those Strike Masters. And you could follow the track of this A400, and he'd been flying straight, and then there's a very definite blip as he purposefully deviated to fly over Silverstone and then went back on his course again. So whether he knew somebody in the area or whatever, I don't know, but he'd very definitely, gone out of his way to fly over. And it was that low that it was like, bloody hell, you could take the roof off.
Oh, he did it for you, Farmer.
Well, he could have warned me beforehand. I'd have been looking out the bloody window.
Oh, sorry.
Yeah, I mean, we do get all sorts of things over. I mean, earlier on, there was a Chinook helicopter just sort of went blatting past.
What's that one you took a photo of in the first half?
Oh, that's a Strike Master.
Oh, okay, that's a Strike. Okay.
That's an example of the two that just flew by in rather close formation. Don't know where they'd come from.
Yeah, there you go. The peanuts can see that one. I don't have to show you.
No.
Okay. Do they serve a purpose other than aerodynamics, those little pods on the wings?
In that case, though, I suspect there'll be fuel tanks. Because I think they're fixed.
Yeah.
I mean, historically, it was a trainer and sort of a light strike aircraft, ground attack.
Yeah. It's hard to tell what the wingspan is in that photo because it's. Yeah.
Oh, they're not very big. They're not very big at all. The wingspan is 11 meters, so they're quite a small aircraft.
Yeah.
But it's surprising because we don't use them anymore. So quite why two just went flying over, I don't know. I mean, they're either civilian or they've come over here from
Fondle said I get planes flying around and low. I get annoyed with them, but being down the road from Duxford, most often it's a Spitfire. So when I see one of those, I don't mind.
Well, Vroom Fondle, it obviously is in the same neck of the woods as where I grew up, because I grew up about, I don't know, half an hour from Duxford. So,
okay.
Like I said, I worked there for a while. Well, voluntarily. It was a bloody good way of getting in the air shows free, because you had a car pass, because you worked there.
Camborne.
Yeah, fair enough. Well, all I'll say is Burwell.
Get rid of that. What's that? Who's on the Discords? Bob's the Science Guy's been running his live stream a lot.
Has
last
he?
couple of weeks. Yeah, he's been showing that what he shows that oh shit, I can't think of the name of it. Where it has that graph on it. Craig didn't get back to me from that DM too yet. He mustn't not worried about it. He gave me a shout out on the end of that Phil stream.
Oh, did he? Well, that's good of him.
Only because I posted in the side chat hello and all that, and I said shout out to Phil. So he read it out.
Bum, bum, bum.
Oh, Chemo's over in debate flat Earth again.
Chemo.
What's that, Paul?
I said, have you got something for us, Terry?
Yes, I'm ready.
Cool.
Ready, willing, and able.
Let's have it.
Okay, let you have it. I'll let you have it. Put that over there. Here we go. Where's Matt?
United Kingdom, the same. One for the non-UK viewers here, or maybe not.
Matt
Some people I actually know in my real life don't know this. One thing that actually causes confusion here is the naming of our country and the islands that we inhabit. And actually it is quite complicated. We'll start with the United Kingdom. The UK is short for the United Kingdom of Great Britain and Northern Ireland. Northern Ireland is a country on the island that the Republic of Ireland occupies most of. The United Kingdom is a sovereign state that includes the countries of England, Wales, Scotland and Northern Ireland. It does not include anything else. Great Britain is the name of the largest island that contains England, Wales and Scotland, hence Great Britain and Northern Ireland. Okay, but what about the British Isles? Well, this is the name for all of the islands situated off the northwest coast of Europe. Great Britain is great because it's the largest of these islands. The rest includes the island which is home to Northern Ireland and the Republic of Ireland, the Isle of Man, the Isles of Scilly, the Channel Islands and 6,000 other smaller islands. The British Isles is more of a geographical term which actually indicates that it's a bunch of islands. The UK is actually a sovereign state, as I said. Now this is confused even further when you watch the Olympics and you see Team GB. This is short for Great Britain and Northern Ireland, but also includes athletes from the Channel Islands, the Isle of Man, and overseas territories such as Gibraltar and the Falklands. Which is why we're not Team UK, because those small islands are not part of the UK. So, to summarise, the UK is a sovereign state. England, where I am, is a country in the UK. Great Britain is the largest island of the British Isles, which is a group of islands off the northwest coast of Europe. There we go, clear as mud. I've been Simon Dan, this has been another Misconception Mini, and I'll see you next time.
It sounded confusing, didn't it?
Yeah, I'm in the garden.
It does, but it is actually
Subscribe
quite
here.
simple.
Yeah.
That's the subscribe button. More videos, more videos.
What have we got here? Where's Wally? Where'd you go, Wally? Oh, there you are. Haven't played a Wally for a while.
No, No, that's true.
Rob Durham, angle to a curve, super easy for flat Earth. AutoCAD Genius, at least it was 2015. Okay, interesting. Can you do an can you do a Matt's voice, Farmer?
No. No, I can't do Matt's voice, but I can say Terry.
Oh yes, Farmer.
Press play, please.
Okay.
But could press play, please.
Okay.
Terry.
I'll do that for you.
Well, thank you.
G'day everybody, where's Wally here? Well, this doesn't happen every day. I have a video in the derp section and in the cool section by the same person, none other than Rob Durham. And I wonder how many of you guys recall that Rob Durham is the fellow who blew compressed air into an aircraft gyroscope that was designed to operate off of a light suction.
This is going to be the subject of this video. It's a directional gyro or a heading indicator. It's air powered. You can see on the back here. I'm sure if you can see it. Let's put a light on it. At the top you've got the vacuum port, so you could power this using a vacuum pump. You've got cage there. I'm guessing you take the bung out and insert something to keep it caged whilst you test it, something like that, I guess. And then you've got the air inlet,
I guess,
which is the one I'm going to be using. So I'm going to be putting pressurised air into this thing. And it just so happened that this standard fitting off a compressor hose fitted the threads perfectly, so that was very convenient. If I turn it around to this side, it tells us not to exceed 20 inch-pounds of torque, so I know what pressure to apply, or not to exceed anyway.
And old mate Wolfie, he got well blocked for asking him why he did that. So Nathan and fellow numpty QE have been singing the praises and citing a video made by Rob recently, claiming that you cannot get an angle from a curvature. This was in the lead up to the debate by refracted curvature and Ruhif. Let's have a look.
Back to the massacre that is elevation angle measurements from a curved baseline. They're going to whistle past it in the initial, or Ruhif's going to try and whistle past it, and that email that you read out earlier. You've been presented with the angles. Shh, let's not talk about where we got them from. That wasn't in the email. How do you plan on getting it back on track in that regard, John?
I'm going to let them go first and let them make the first move because, like Brian described, they don't really have anywhere to go. I just want to see where they try to climb through the minefield.
Would they let you play, I don't know if this has been talked about, just a short, like 1 minute clip off a video? Is that possible? Could you like send it to them? Because the 1 minute clip is the clip from Rob Durham, where he actually uses AutoCAD and puts a triangle on a sphere and then tries to get the angle between the adjacent and the hypotenuse.
Error. Someone dig that out. I'd like to play it right now. If someone's got that video, can you stick it in Skype? Subscribe today to Rob Durham. You'll know why in a minute.
Well, that's just a side effect of projecting the flat plane up onto the celestial sphere. You know, it kind of throws everything into confusion.
Boom. Right, you're way ahead of them then. Yeah, that's done after you've begged the question. Oh, I like you, John. I like you a lot.
John is dangerous.
See if it does.
Yeah, 1 second. It's 8:09.
No, it has. It's taken me straight there. Perfect. Can I show Rob Durham? Yes, I can. Okay, so this, for the audience's benefit, is Rob Durham's channel. So check it out, Be Here or Be Sphere, for Rob Durham's videos, and you can subscribe by typing in Rob Durham's name and coming to this channel. So there he is.
Okay, to briefly touch on what the guys over at Flat Earth Debate have been saying, we're going to use the exact same examples of the GP positions here. I'm going to look at it from an orthographic view. Okay, if we're standing here on the Earth, this is the angle to the celestial body. Let's take a line from our position, representing the horizon. The angle formed here is definitely not 90 degrees.
Hey?
And even at the position where it meets the Earth, you can't have a 90-degree angle to a curved surface. And AutoCAD will actually verify this, because if I choose the angular dimension command and I pick this line and this line, it will give me an angle between them. If I try to pick this line and this arc, it says here object selected is not a line, so it will just not give me an angle. And why would it? How could it? The angle will be different at every single point on that arc. 1. Where are you getting your 90 degrees? 2. Where are you getting your straight line to form the 90 degrees? And 3. Where are you getting your circle of equal altitude? Because from what I'm seeing, none of them are available to us using a sphere.
Thank you to Rob Durham. Subscribe today.
That's the death of the ball tart spinning space monkey religion in a minute, under a minute.
Or to summarise his 3 questions, how can you get an elevation angle measurement from a curved baseline?
Cannot compute.
You can't, is the answer.
Oh, I love how Rob finishes up there. The angle would be different at every single point on the arc. Exactly. You can get an angle. It just happens to be different at every single point. And luckily, we only want to know where the angle is at one point. Oh, did you catch what Rob did there? Here, I'll play the interesting part again.
You can't have a 90-degree angle to a curved surface. And AutoCAD will actually verify this, because if I choose the angular dimension command and I pick this line and this line, it will give me an angle between them. If I try to pick this line and this arc, it says here, object selected is not a line.
So did you see Rob's trickery that time? Well, first he measures angle A. Well, that is the angle between 2 parallel lines of parallel light from stars. That ain't right. Then he tries to measure angle B between the sight line and the arc. Well, that's never going to work, is it? Now, what Rob doesn't measure is angle C. He could easily do that, yet he doesn't. Yeah. And we have to wonder why. But wait, it gets better. Now, once you have the angle to the tangent, the next step for celestial navigation is to find the co-angle. Minus it from 90, as 10th Man so eloquently says. And the fact that the numpties are spruiking this video by Rob shows that they actually have never even done a full sight reduction or completed the celestial navigation. We all saw Refracted Curvature's really weak source effort with Ruhif and the debate the other day. Okay, guess what? It gets even better. QE and Nathan both say Rob's the man. Oh, and shout out to Harry Callaghan for this little gem. Now, I will steal Harry's point here. It seems that hanging around flat earthers makes one dumber. Now, Rob had absolutely no problem drawing elevation angles to the curved surface of the globe back in 2015. Let's have a quick look at Rob trying to test the sphere model working. He basically used SunCalc, found 3 locations, and for each location he got the SunCalc elevation angle and azimuth to the sun. Now, he triangulated the sun from the surface of the Earth. With AutoCAD, Rob drew 3 lines. He drew them at the azimuth and elevation angle given, and he did this to the surface of the Earth, which was curved. He modelled this rather well.
So to show this, I've drawn the circle from my hometown location. I've drawn a north line here, which points at the North Pole up here, and from the website, the suncalc.org website, it told me that my location is 85 degrees, or sorry, the sun's position from my location here in the centre is 85.71 degrees. So I've gone in an eastward direction clockwise. That gives me this line here. And then the so that's the azimuth. Then the altitude is the angle formed between this horizontal 85.71 degree line and the line of sight up towards the sun. So just spin it around a bit so you can see it a bit better. So they're the angles we're talking about, and that's how I am determining the sun's location on all three points on the Earth.
Now Rob made all three lines 93 million miles long. Then he drew a scale sun at that distance. And guess what? All three lines terminated inside the sun.
But it still falls within the confines of the sun, as it's so large in the globe model.
And guess what? It gets even better. He then tried to do the same with the AE map, and no prizes for guessing how well that worked out. Okay, big hint, it didn't.
Anyway, let's get to the flat Earth geometry. So this is the Gleason's new standard map of the world, which I've imported into AutoCAD. I've traced over the lines of latitude here with circles in AutoCAD, and because it's been scanned, the lines don't actually match the circles precisely, but they're not far off. And as you can see, they work out pretty good on the map. There would be the red line would be going through London as the meridian. There's my location. That works out in South Africa, and that works out in Sumatra. It's pretty accurate. I then drew the line of, or the angle of azimuth. I tell you what, I'm just going to turn the map off because it slows panning down when I'm going into 3D. So here would be, this would be north, facing this way. So measuring an angle eastward from north, going around this way, this would be the azimuth angle, and then up from that angle would be the elevation or the altitude angle here, which points off up into space. I did that on all three, and as you can see, none of them converge.
Now that's the death of flat Earth right there, hey QE? Hey QE. Turns out that getting an elevation angle from a curved surface is really easy. Even past Rob could do it rather accurately. Now the globe matches reality and the flat Earth matches diddly squat. And none of these converge.
And it turns out that the values and the angles on the SunCalc website and others like it are in fact correct, then I will have to concede that the world, or the Earth, is a globe.
So let's just have a look at Rob's words here. If the globe is correct, then I will have to concede that the world is a globe. Well, so maybe we should all pop over to the comment section on Rob's video, on that really old video, and offer to help Rob come to grips with the questions that he raised 7 years ago.
But I will need some help. And what I'm going to ask for is for at least 2 people, myself as a third, but preferably 3 other people, who have the means and the capability of determining azimuths and altitudes to the sun with whatever equipment you may have, and to coordinate yourselves so that you can get the angles documented at the exact same time of day in all 3 locations, and get them back to me, and I can punch them into this model and determine exactly what's going on.
Okay Rob, you want to get the exact angles to the sun or a celestial object. Now if you still want to do this, then Wolfie and myself, and I'm sure Dr. Bob would love to play too. Now we all have uber sextants, and we can all get very, very accurate angles to the sun or the moon at exactly the same time. Or better yet, Rob, and I'm hoping that you're watching this, I have an idea. On 2022, the year of our Lord, at the 3rd month, 25th day, at 14:000 UTC, Wolfie was in Tucson, and I, as always, was in Brisbane. And we measured the angles to the moon from our locations at the exact same time. Now, the software we use puts accurate timestamps in the file, and along with all the lovely things that you might want to use, like lat, long, elevation, azimuth. Now, if you want a third point, it turns out the Nautical Almanac will provide. The GP of the moon is also known, so I guess that angle isn't too hard to draw now, is it? Big hint, it is straight up. Now, I'm looking forward to seeing your thoughtful analysis, Rob. So here's all that data. And for the final word and the final wrap-up, we have a well-considered opinion by the familiar expert on all things flat Earth. Thanks, guys.
Emma, what's this called?
The AE map.
The AE map?
Yes.
And where's the globe?
This.
Which one does the Earth look like? You know, there are some people who think the Earth looks like this.
Yes.
What do you think about them?
They are like this.
Yeah, I agree.
Yeah. Love it.
Yeah.
Oh dear.
I don't know if she'll grow up and be a debater. But what exactly is mass and how is it formed? The answer may surprise you.
Ooh.
Dun 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 dun.
About some relatively incredible but somewhat unexplored discovery that came from the Jefferson Lab located in the US. The lab, whose main purpose is to investigate the nature of matter itself, with the scientists in this lab doing so by trying to learn as much as they can about various subatomic particles. And so if we have the Hubble telescope and the James Webb telescope exploring the universe and looking at the universe from the outside perspective, on the other side we have scientists from the Jefferson Lab doing the opposite, looking on the inside in order to understand how the world on the inside looks like as well. And naturally there are quite a lot of these labs around the world. A lot of them usually deal with particle physics and use a lot of different particle accelerators to try to get the data. But in this particular case, the scientists in this lab have actually accidentally discovered something amazing about the mass in the universe. At least amazing for the particle physicists. But before I talk about this and what the scientists found here, I actually wanted to bring up several other articles that I did not cover on this channel for a very important reason. And the reason is really simple. There's unfortunately a bit of a divide nowadays between the actual discovery in various scientific papers and how the media portrays it, usually through very clickbaity titles. Now, my apologies for possibly doing this in the past as well, mostly because I didn't really realize how misleading this can actually be in the long term, but here's one good example from just a few months ago. An article from Boston College published this press release claiming to have discovered an elusive particle with the material containing something they refer to as the axial Higgs mode. And all of this got picked up by the media pretty quickly, and this axial Higgs boson eventually even got its own Wikipedia page. Luckily for us, this page no longer exists because this axial Higgs boson is not really what the scientists found in that paper. And the paper itself doesn't even mention any specific particles. As a matter of fact, it mentions something completely unrelated to the iconic Higgs boson. But one thing led to another, and eventually this news spread, with quite a lot of different sources picking it up. And I actually wasn't sure how to cover this, but eventually realized that, well, this is not obviously the first time this happened. And by the way, nothing particularly exciting was discovered in this paper, nothing revolutionary or nothing related to the Higgs boson. So yeah, axial Higgs boson is not a thing. But speaking of Higgs boson, I'm pretty sure most of you have heard about this, because back in 2012, this was the biggest scientific hype. The discovery of a subatomic particle, the particle that was even described as the God particle that essentially makes mass in the universe happen. The particle named after Peter Higgs, who predicted its existence back in the days. But the thing is, even back in 2012, this was a bit of an over-exaggeration and a hype that should not have happened. I'm not entirely sure why it went out of control, but the discovery itself was also not super groundbreaking for one important reason. Higgs boson only actually explains 1% of mass of everything. it does not explain all of the mass in the universe. And so even though it was called the God particle, it's basically only 1% God particle. It only gives mass to very specific subatomic particles, the ones responsible for the weak force, W and Z boson specifically. Which is one of the reasons why Peter Higgs was really disappointed about how much attention all of this got. But what's a little bit more unfair, and I guess somewhat more surprising, is that the new discovery from the Jefferson lab received practically no attention anywhere, even though it was a much bigger discovery than the Higgs boson. And more importantly, it actually kind of explains 99% of all of the mass in the universe. Alright, let's step a few steps back and talk about the mass. Actually, it's a really strange concept. Now, obviously most of us have some kind of an understanding of what mass is, but I think conceptually it's more or less different for everyone. Now, first of all, weight is not the same as mass. When you weigh yourself on a scale, you're getting mass times acceleration. Not really the same concept. However, your mass is still the same even if you go to space, where the acceleration is a little bit different. As a matter of fact, in one of the older videos, I even explored the idea of having a tiny object orbit around you, because both you and the object will have mass. And so if you're in space and you put an object relatively close to you, it eventually can acquire an orbit around you. That older video should be somewhere in the description. And obviously, as the object becomes more massive, it sort of acquires more gravity and starts attracting objects even more. The most extreme example in this case is of course a black hole, an object whose mass is just way too much. Even the light cannot escape it. But the question is still, so okay, what exactly is mass though? Where is it coming from? Well, I guess one way to answer this is to look inside the atoms and inside the particles that all these objects are made from. For example, here's a helium atom. We have the electron cloud around it, but a lot of its mass is concentrated in the middle, where you see 2 red protons and 2 neutrons. The mass of the electron in this case can generally be ignored, it's relatively small. And so it looks like most of the mass in this atom comes from the protons and the neutrons. But then if you start zooming in even more, you'll discover that both the proton and the neutron are made out of their own subatomic particles. We refer to them as quarks. For the protons and the neutrons, the quarks are up quarks and down quarks. This here is a proton, this here is a neutron. A very small difference, with this being a result of the weak force, but we've discussed this in one of the previous videos that should be in the description. Okay, so where's the mass though? Well, here's the thing. When the scientists a few decades ago started to measure the mass of these quarks, specifically the up quarks and down quarks separately, and they did so by conducting a lot of particle accelerator experiments where they collide a lot of different particles, creating subatomic particles and observing the effects, they quite shockingly discovered that the up quarks and down quarks only represent a tiny fraction of the total mass. Yet the proton itself and the neutron itself were much more massive than they should have been if it was just the up quarks and the down quarks. So where is the mass from? And well, in the last few decades, the scientists were finally able to kind of answer this, with the work from the Jefferson lab right here more or less answering this once and for all. And more importantly, even creating a beautiful simulation to kind of help us visualize all of this and to help us understand where most of the mass, or 99% of all of the mass in the universe, and we're talking about mass inside various stars, inside various gas clouds, and in pretty much most of the objects out there, comes from. And the actual answer and the result are kind of counterintuitive and somewhat difficult to understand. It comes from the gluons connecting everything together. It comes from these squiggly lines. And this particular image doesn't really do it justice, because most of the mass of the entire proton and the neutron is in these squiggly lines. This mass comes from the energy connecting and holding the quarks together. Or at least that's one way of thinking about it. The much better way of visualizing this is through this new simulation. So here's how we previously imagined the proton. We have 3 quarks interacting with one another, with essentially a force holding them together. But in reality, the proton and the neutron would probably look something like this, with all of these white patches you see, essentially creating these large clouds of gluons that then carry the strong force, which essentially creates the mass. And this by itself is, to me at least, kind of mind-blowing. And since individual quarks in this case are only responsible for less than 1% of the total mass, it's really these gluons that create pretty much all of the mass around us. Not Higgs boson, not the tiny quarks inside of our bodies, but the strong force holding them together. But wait, it gets even more counterintuitive and weird. It's not the gluons themselves, it's the energy of binding. And I guess more specifically, the motion of the gluons and their speed. By themselves, each individual gluon doesn't actually have much mass at all. When the scientists originally measured individual gluons through various particle accelerator experiments, they determined that its mass was absolutely minuscule. So once again, where is the mass coming from? Well, it turns out gluons are mostly massless at short distances, but as they travel further away, they tend to acquire mass. Or I guess to be more exact, they acquire the binding energy, which then binds the quarks together. And in this case, the scientists believe it's because the quarks tend to gather the clouds of gluons as they move across larger distances. And so even though the mass of the individual quark is small and the mass of individual gluon is minuscule as well, the motion of the gluons creates all of the mass on the inside. And so this weird cloud you see, that's gluons moving around, creating the mass inside the proton. And honestly, even today, I personally have trouble sort of wrapping my head around this. How exactly can mass be formed by the unusual interaction of these gluons, and essentially by them just moving around, and then somehow binding quarks together, and thus generating the mass in the entire universe? 99% of all of the mass. Which then obviously generates things like gravity, which generates a lot of other effects we observe around the universe. Very hard to conceptualize, somewhat difficult to understand, but thanks to the scientists from the Jefferson Lab and the MIT, we now have a slightly better visualization, allowing us to kind of see this and allowing us to kind of understand what's happening, at least to some extent. But that's actually not the new discovery. The most recent discovery, from I guess just a few weeks ago, is more or less accidental. And it's from this study right here you can find in the description below. And all of this comes from a completely different experiment that was actually shooting various electrons at various protons and neutrons, designed to study proton and neutron spin. In other words, the scientists were actually studying something entirely different, but they were doing so for nearly a decade. And so over this period of time, they've collected a huge amount of data about protons, electrons, and neutrons. And recently they realized that they could actually combine all of this information to extract the overall strong force coupling and how it affects protons and neutrons on the inside. In simpler terms, by combining all of this data from these experiments, they were actually able to see what's happening to these squiggly lines. And specifically, they were able to calculate how the strong force changes as the distance between quarks grows as well. Mostly because it's still not entirely clear if the force grows exponentially, if it stays the same, or if it maybe decreases because of the distances. And in this case, the scientists were able to calculate the strong force at the largest distances yet, determining that at larger distances, the strong force seems to actually stay the same, whereas at shorter distances, it's relatively weak. Which also proves that gluons in this case also get their mass from the force of coupling, or basically that 99% of all of the mass in the universe is formed by the force that's holding things together. And in case of these squiggly lines, once they get far enough away from each other, the force between them will stay relatively same. But even though this is a pretty major breakthrough, it still is far from actually explaining everything about mass to us, and there are still so many unanswered questions. As a matter of fact, not so long ago, we've even discussed some of these potential problems discovered in the particle physics that could maybe rewrite some of these ideas. But at least for now, it definitely looks like the idea of mass in the universe is more or less understood by the scientists and seems to come from the force between gluons acquired through their motion, which binds subatomic particles together. Something that's still kind of difficult to imagine, and even more difficult to understand, but at least for now seems to be physically proven and described in some of these new studies. Although I'm sure once new discoveries are made, I'll be coming back and talking more about this, because personally I find this topic really fascinating, even though it's super counterintuitive. And if you'd like to learn more about the research and some of these new discoveries, including these visualizations, check out the MIT video in the description below. Anyway, on that note, thank you for watching, subscribe, maybe share this with someone who loves to learn about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.
Bye bye. And hello.
Hello. Bye-bye.
Quarks. Strangeness and charm. Good old Hawken. They knew what was what.
I'll finish off with Simon, I think. That'll be it.
Oh goody, mud floods.
That's all we need.
Yeah. Yeah.
Flood walkthrough videos, and so far I've not done any within the UK. But this week I found one in the UK and I am desperate to have a look at it. Hello all and welcome along to another episode of Tinfoil Tuesday with me, Simon Dan. Thank you very much for joining me. Before we begin today, huge thank you to the sponsors of today's video, Omaze. I'm super excited to be working with Omaze to offer you the chance to win an Audi RS e-tron GT and support a fantastic charity like Oscar's Kids. omaze.com/Simon and enter today. Right, back to today's video, and before we get started with this mud flood stuff, a short retraction/statement from me. A couple of weeks ago, I was debunked thoroughly by someone else in the debunking community called Logicked, and I was extremely happy about this. Last month, I published this video, in which I looked at a certain conspiracy theorist who was discussing what he thought was an alien invasion fleet on the ISS live feed. I claimed the stuff he was seeing was debris from an old exploded rocket motor. And I even said this: that looks how blown up rocket motors should look, to be honest. Now, I should not have said that. And as Logic so brilliantly pointed out in his debunking of my video, it was an incorrect assumption. Let's listen to Logic to explain what it really was.
Well, yeah, the largest portion of the craft, that being the Earth, is cloaked, at least on the nighttime side that we're on, by nighttime. And Houston, Texas here slipped through the cracks because it's an enormous city full of lights. As soon as you saw that sort of wheel and spoke lacy pattern of lights, that kind of spiderweb shape, frankly, it should have been instantly obvious generally what you were looking at. Not that it was Houston, that took me some effort to figure out as well, although I don't think it was that hard. I don't think it took me more than about an hour. But only one thing looks like that when you're looking down at the Earth from space at night.
Now, for some reason, I was adamant that that footage was being shot away from Earth, from the ISS, as in towards deep space. And it never once occurred to me that it was looking towards Earth. I should, however, have double checked. I went with the exploded rocket motor explanation because it seemed the most feasible and the date sort of matched up as well. But I was wrong, as Logic pointed out, so this is a retraction and correction. The lights were, of course, settlements on Earth. Thank you to everyone who pointed it out, and of course to Logic for thoroughly debunking me. This is what science is all about, and I could not be happier that we ended up with the actual truth. Right, on with the show. Dave Ebony is a YouTuber who spends time giving people explanations on the mud flood. And today he's taking us around a city in England called Sheffield. In particular, one called Victoria Hall, a Grade 2 listed Methodist building. Grade 2 listed here in the UK, by the way, means the building has particular historic and/or architectural significance and is subjected to regulations which protect its unique character. Right, come on then Dave, away we go.
Hello, Dave here. Welcome to another video. Long time since I've done any videos like this out on the street. But when I saw this building I couldn't resist really. Because it's what we call, or I call, a pre-reset red brick building.
Right, so if my understanding is correct, that means a pre-mud flood building. So built before the mud flood. Well, this building was built in 1906, replacing the Norfolk Street Chapel, which was built before it in its place. The old Norfolk Street Chapel was built in 1780, and only a foundation stone remains in the Victoria Hall rebuild. So this red brick building was built in 1906 then. Are we expected to believe that the mud flood happened after that?
Now what that basically means is that building, I would think, will have a Victorian build date on it.
Not quite. The Victorian era ended in 1901, but they did name that hall after Queen Victoria.
But as you go looking for the evidence, you quite often find that's not true. Most of these red brick buildings were built long before the 1800s.
Well, bricks were used in England as far back as the 12th century. But your comment doesn't really prove anything, because the UK sits on swathes of clay. It can adapt very well to the ever-changing climate here in the UK, and it is waterproof, so why not use clay?
And they are all mud flooded.
Are they though, Dave? Because there isn't really any evidence for this, is there?
What that means is they've got levels below ground, but them levels below ground were once
we're not allowed to have a basement.
Opened up onto the street.
Yeah, basements.
A basement level is extremely common, or was back then in the UK. I don't see how a basement level is proof of a mud flood.
Sounds bad, I know. But I'll have a look around the side and I'll show you what I mean in a minute. Now, these type of buildings, this has been converted into a hall. But that's all you need to do, really.
Oh, gravity reset itself there for a second.
Is that a few crosses, a few religious statues, and you got yourself a church?
Well, it was built for the Methodist movement, so I'm not surprised.
Because these buildings in the 1800s, they were converted into all sorts of things. Churches, government buildings. But the beautiful tower up the top there. Now, a bit shaky, but you come down and come back out a bit. Across the top. Right across the top, you have your tower there. When it was built, there would have been a tower exactly the same on that side.
Would there? The Victoria Hall's own website has this image on their about page. No second tower. Unfortunately, it doesn't show the date of this photo, but black and white photos were still the norm in the 1950s in the UK. So it must be at least then, if not older.
I don't know, maybe it's been bomb damaged, whatever. I don't know. But it's just another example. I forgot to say where I was actually. I'm in the Victoria Hall in Sheffield.
Yeah, we saw, mate. It's fine.
It's on Norfolk Street. Now we'll have a wander along the side. There's not a great deal to show on this as it goes. It doesn't have that many features, but you know, just look up the road. All these buildings, they're all built in another time.
Well, I've learnt something new there, Dave. Thank you.
They weren't built in Victorian times like we're told, and like the history books tell us. So we'll have a walk along the side, see what it's like along here.
Oh, you get some nice boots in there.
So I don't know the history of the town. It's got a cross on there, so it possibly is a church.
Come on, Dave, you're giving us a mud flood tour and you don't know anything about the building's history? How could you possibly be correct about the mud flood if you don't know anything about this?
Well, as we'll come across and see here.
Yeah, basement.
I think these are the tops of full-length windows.
How dare they build small windows in the top half of basements to let light in? But to be fair, they weren't to know that people were claiming that this is mud flood evidence years later.
You know, these... Nobody, no architect, especially on a building like this, is going to put windows where slightest bit of, you know, muck, gravel, straight into your windows.
Do they have to open, or can they just let light in as designed? Building half basements like this was very common in the UK in the 1800s and the early 1900s.
Doesn't make sense, does it? Yeah?
Yeah, doesn't it?
And it's right away along here. Say this is only a short one. It's not really that much detail to the place.
was waiting
actually,
to
I'm
run
going to have
into
to
the
stand
pole.
corrected on this because up there, I think, is the date. Yeah, what does that look like? 1780, shaken. Yeah.
Indeed, the original build date for the Norfolk Street Chapel.
Right round the side of the hall now. Falling off the curb here. As you'll be able to see as we go along here, classic mud flood building. What this basically means is, I'll step back and show you. See, your windows up the top there. Turn round again. See the archway? Exactly the same there. But that's just the top of the
Wow, what a
arch.
coincidence in the architecture.
Yeah.
The bottom of the arch of the windows is right down there. So I would say that's about, I don't know, 8 to 10 foot. But I would say that there's another level below that as well.
You would say, do you know if there is? Have you been there? Have you been inside? No. So instead of speculating and coming up with God knows what theory about this place, go in there, learn some history and realise it's no proof of a mud flood whatsoever. Sorry everyone, these ones annoy me and please me in equal measure. So we're going to leave Dave here for today and wrap up another Tinfoil Tuesday. I wonder if we'll have another look at Dave at some point. He's got a few mud flood tours, I think. But for now, we're all done and dusted for another Tinfoil Tuesday. Thank you so much for joining me. I really do appreciate you watching. If you enjoyed it, please do consider subscribing to the channel. And if you liked it, hit that like button too. As I said, I've done a few of these mud flood tour videos. Go back, check out the Tinfoil Tuesday playlist. You'll find them on there. Just enough time to once again thank Omaze for sponsoring today. Remember, for your chance to win an Audi RS e-tron GT, and support the brilliant charity Oscars Kids, then just head to omaze.com/Simon to enter. I've been Simon Dan, have yourselves a great day and I'll see you all tomorrow for another Misconception Mini. See you then.
There we go.
Yeah, the mud flood thing is particularly
to
What have they
quote,
got little windows in basements? Well,
to quote,
let the light in.
To quote Timbo, I think mud flood is more stupid than flat earth, if that's possible.
Yes. It certainly is equally stupid.
I've never been able to figure out what they're on about. It makes no sense to me.
Oh, hello, Blue. When did you sneak in?
Hello. G'day, mate.
G'day, mate. I can't work it out. Just because we've got basements, it's mud flood.
Yeah.
Is that because it used to be the first floor? Is that what they're saying?
I think that's what their argument is a lot of the time. Yes, where we just see a basement, I think they're presuming that that wasn't the basement. That was what you call the first floor, what we call the ground floor, and it's all been buried and it's now being rediscovered. And yet it only seems to happen in very localized places, you know, because if you come out here and dig down in the ground, you'll just find, well, dirt.
Yeah.
There's no buried buildings out here. I mean, admittedly, you can go out into various parts of this countryside and not dig down very far, and you can find yourself finely tiled Roman floors. And sometimes they're only a foot or two down. Because, you know, a while back there was a Roman building there and it's gone, but the floors managed to survive. And if you go into the larger cities like London, you'll find that London got built on top of London that got built on top of London. As happens in these, you know, it's happened in these places. But the whole idea of a mud flood is just under the mud flood, and there's always some sort of reset that goes with it, so that nobody knows or remembers there was this mud flood. It's just it's out there. It's way out there.
No, there's nothing really you can say about those mud floods. Can't. Haven't got a thing.
Yeah, I mean that's why a lot of them argue that there's a reset, because if there was a global mud flood, surely we'd have history of it.
I had to laugh at the
But
one
no,
for Australia. They showed the bloke walked around Australia, a couple of Australian buildings, just because they've got a similar design with basements. I had to laugh at that one.
Yeah, I think I know the one you mean. Yeah.
So
I mean, it is just as equally ludicrous as flat Earth.
Yeah, so we've had a mud flood since, the last couple 100 years. Okay.
Yes, but you've had a reset too, which is why there's no history of it. That's the sort of shit they have to make up to, cover these things. Well, how come we haven't got a history of it? It's because there was a reset. Right.
And you probably would have got all the answers for the quiz too today, Blue.
I got the last couple.
No, there you go.
Oh, you're on your phone, were you?
Yeah. Only I had to wait till I could hear Paul read all of the answers because I couldn't read them on my phone. They were too little.
Oh, okay.
Yeah, I'll bet.
We're trying to work out who's this True Blue in the chat. Naked True Blue. I'm going, who's this?
Who's that then? Who's this imposter?
I snuck in. Asher looks in the chat's got me confused. He says, how did you name the shed/hall for your gizmo? I need more information. I don't understand the question.
It's not referring to your Cavendish, is he?
Well, I sort of thought that, but I don't understand what he means.
Yeah, I don't know what he means either. Shed.
Because you did that out in your workshop, which I'm presuming was your garage.
Yeah, the garage. Yeah.
Yeah.
That's what
it
you
doesn't have a name.
Yeah, that's the garage.
Yeah.
Well, it started out that way. It's a shop now.
Yeah. Well, as is the way of these things, yes.
That's like my garage. I don't know what I'd call it, if it's a workshop or a garage. It's got a car in it and tools.
Mine's technically, mine is still a garage because that's what it was, and it's got a motorbike in it. It ain't got a bloody car in it. It wouldn't fit.
If I had all the setup, I'd make a video of installing wheel bearings to the rotors out there, but I haven't got the gizmos to hold my phone and set it up. And
yeah, when you try to do that, you realise just what's involved.
Yeah, that's what I thought. To set it all up, have it stand there, get it the right position, and
you need something like my selfie stick that's also a tripod.
Yeah.
And you could probably set it up on the floor at a height, and then just let it film as you get on with it.
Yeah, remove it, and then I'd have to move it again to go up onto the bench to do
That's
the bearing
it,
part,
yeah.
and then show everyone how to pack a bearing, all that sort of stuff.
Yes, Zebulon, it must have been a worldwide mud flood, because if it was local.
Yeah, it wasn't local. It was the whole world.
Had to be. Yeah, it's like all of these other bizarre theories. As soon as you start looking at it, it just falls apart. It's like, no, hang on a minute, that how would this work, and why that, and
And they throw the giants in too, because a lot of the windows and doors were really tall for letting light in. And
now, that really does get me.
Stuff.
You look at when these particular buildings were put up, and they have very tall grand entrances, and these entrances usually open out into courtyards. Why is that? Oh yeah, horse and carriage.
Yeah.
Yeah.
Well, you don't want to hit your head on the top of the doorway.
Bloody right. And of course, if you want to make a statement, you have a very big, imposing front door, don't you? because why not? Yeah, where did all the mud go? Well, this is it. It's dried out and turned into earth, and that's why you've now got lots of buildings with basements.
Where did it come from? That's an even better question.
Wow. Yeah. I don't think that's ever been answered.
It doesn't rain mud. We know that, right? Well, I guess maybe it could. With enough wind.
It come from all the mountains. That's why there's no mountains around anymore. They're all washed down.
That could be it. Maybe that's why your country is so damn flat.
Oh, so it wasn't glaciers then? Eroding our land away to give us impressive valleys and stuff. And leaving behind all those pesky erratic boulders.
That reminds me why the Grand Canyon, where all the soil went from that to make the moon.
Oops.
I only got
you
the
literally
tail.
got
I dropped into the tail end of your stream, Blue, but I was a bit preoccupied. I wound it back a bit and thought, yeah, I don't know if there's anything out of it I could grab.
Yeah.
Who'd you have on? I think I seen Gary at the end. Was Gary on that? Or was that another?
No, Gary, I don't think. I don't remember.
Another
Gary,
one.
yeah. No, Gary didn't show up. Dan the Waterman showed up.
Dan the Waterman. Oh, that's the one I was listening to.
Leakey was there for a while.
Yeah, I was listening to Dan there for a minute.
Leakey hopped in for a little while, but Hawkins immediately ran him off.
Oh. Sean had a birthday the other day.
He did.
He's not as old as us yet. Oh, except for you, Farmer, sorry.
Aha. Yeah, well, I'm a youngster, and I.
How old is Sean?
I think it was it 60?
57, 58, 59? Oh. I think he's around there somewhere.
I thought it was his 60th unless I'm thinking of somebody else.
I know he's a fraction younger than me. He's not a fossil yet, like some people.
Hey, I resemble that remark.
Yeah, I think it's his 60th.
Okay. And I know Bob, the science guy, is a fraction younger than me too, as well. 57 is so old.
Oh, Keystone.
Oh, mud is horizontal. There you go. There's a quote from Stewie.
Is it horizontal? Oh, that's nice, that, isn't it? God's teeth. Bloody bloke.
Biggest Dogger said, so they built the newer buildings on newly laid down mud. I somehow doubt that. New game. What's that, Brian? Put a link out there for something. I have a sticky.
And we still quite happily dig basements.
Planets form in a disk. What's this? Law and physics. Proto Planet Express, a video game based on hydrodynamic simulations. Okay. I won't play that.
Oh, dear me.
Yeah. Oh, we've been going for 3.5. Oh, we'll wind it up. Gotta let Paul go to look. Gotta let Paul go to bed to get his beauty sleep.
I need a lot of that.
Yeah, we'll see you next year.
Oh. Dear, dear.
Yeah, sleep doesn't seem to help it for me. It just moves the wrinkles around.
Yeah, you got to put your face back on the other side again after it's. Which side you been sleeping on? Oh, that side.
If I spent a day down the beauty parlour, that'd be just for a quote.
Now, did he need to ring me or not? Somebody just rang me and hung up again that quick. My phone didn't even get to ring.
Okay, that was quick.
Yeah. All it managed to do was buzz on the desk. Oh, well. I guess if he wants to talk to me, he'll ring me back. It was like, yeah. Oh, no. Okay.
I've been getting phone calls on the house phone the last week. You know, the odd couple. I look on it, private caller. Okay, if that's important, they'll ring us on the mobiles because they'll have our mobile numbers, obviously. No, don't hear the mobile ring. I bet you'll be telemarketer.
I don't answer any of those.
Well, it's the home phone, so we give out the home phone sometimes to most places we are, and we give them our mobile as well. So.
No, there's only one person who rings the landline.
Telemarketer.
Mother. I don't need to. Of course, you always do out of habit, but I don't need to look at the screen. If the landline here rings, then I know it's Mum, because she's the only person who rings it.
Yeah, for me, it's one of several drugstores or maybe the doctor's office, reminding me that I have to be there.
Yeah, they give you that pre-call to say, you got a doctor's appointment.
Yep.
Oh, bloody Guy's Hospital. I mean, they'll send me text messages after text message after text message saying, "You remember you've got an appointment." Yeah, I know. I made that appointment 6 months ago because I only go every 6 months. And it's just like, yeah, I know. And then a few days later, another text message, and then another text message. It's like, and I've said to them before, can you please stop sending me all these bloody text messages? No, it's how the system's set up.
Yeah, they always tell me to please be there 15 minutes early, which means that I get to wait for an hour and 15 minutes instead of just an hour.
It's not like the bloody airport. You're not going to put your luggage through or anything, you know.
I always ask them at the desk, Blue, how many people before me.
Yeah. Well, I've gotten sneaky. They take you back, stick you in one of the rooms, and then you just sit there and stare at the walls.
Yeah.
Yeah, you go in, and within 5 minutes, they're calling your name. You're like, yes, right. Yes, here we go. All right. We're on it. No, you're not.
I just move you from room to room to make it look like you're getting closer to the doctor.
I just go in, lay down, take a nap.
Well, when I go to Guys in that particular clinic, I can always spot who hasn't been there before, because what they always do before you go and see one of the doctors is they'll call you into room 1, where they'll take your weight, your height, and your blood pressure. And you can see people who've been sat there for a while and their name gets called and you can see the look on their face. Right, finally. And they go in this room and they come out a couple of minutes later and you can see yeah, they got you as well, didn't they? You thought you was going to see the doctor. Now you got to sit down and start waiting all over again.
I used to go to a medical centre in Melbourne where there were like half a dozen doctors, but only one of them was actually any good. Because everyone wanted to see that doctor, but she wouldn't take appointments. She refused to actually take appointments, and she would only turn up at 1 o'clock in the afternoon and then only see about 5 or 6 people. And so you'd have people sitting there from 9 o'clock in the morning, and when the receptionist stepped up and said, anyone to see such and such a doctor, there'd be a rush of people to the desk to get in line. And only about 5 or 6 would actually get, and the rest would have to go home and come back the next day and hope that they got their chance to see this doctor.
Christ.
It was just crappy.
I mean, I consider myself fortunate if I get to see the same doctor twice in any 2 or 3 year period, because Guy's Hospital's a teaching hospital. So they tend to rotate in and out all the time. There are occasions where we sat down and they sort of said, "Have I seen you before?" I think you might have done a couple of years back or something,
Doesn't it get to the stage now where you go to the doctor and you've got to wait so long you nearly forget what you were going for?
No.
What are you here today for? I forgot.
No, in all credit, my local doctors, and I'm invariably there to see my diabetes nurse. I generally don't have to wait any more than a few minutes. They are usually quite good, and they have realistic time slots. You ain't there in a 5-minute time slot, knowing you're going to be there for 10 or 15 minutes, because that's quite often what hospitals do. They just give them 5 minutes at a time.
I got to make sure I keep an eye on my tablets if I'm nearly running out for the repeats on the script, to make sure I book in for the appointment for the doctor, because I ran out of scripts there about a month ago and I had to wait to get to the doctor, and he was on holiday, so I had to wait till he got back.
Yeah.
Well, I said me. Sorry, Blue.
Yeah, for me, I guess the only good part about waiting is maybe something else will go wrong while I'm sitting there.
Yeah.
Which will save me a trip.
Yeah, it will do. It will do.
That's one way of looking at it, I guess. Yeah.
Yeah, I like that one. You wait so long, you've got another illness or something that comes up.
Oh dear.
Blood clots in my ass, mainly.
I did have one at Addenbrooke's Hospital in Cambridge that they had literally had me waiting there 2.5 hours at least. I was absolutely furious, and then they got me in and took me blood pressure, and it was 190 over something. They said, "Why is your blood pressure so high?" I said, "Because I'm just about ready to kill somebody." You kept me waiting out there so bloody long, and I watched you all sod off and have lunch. That didn't happen again.
Well, it looks like we're finished for the day, evening, morning, wherever you are.
4:21 in the afternoon.
Ours is 1:21.
There you go.
It's good being on the same minutes of the time.
Yeah, it helps.
Well, thanks, Farmer. Thanks, Albert Michelson.
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 Okay, Michelson.
Yeah.
Potato.
Spud. Oh dear.
No, we didn't see Blue's late note because he had to get to the doctor first for the late note, and he hadn't got to the doctor yet, so we couldn't get the late note. So
that's right.
Yeah.
But we knew where he was going. That's the main thing.
Exactly. Ah, bugger.
And I forgot to get the note
All of that.
I've got to
Oh, I
change
don't
my
know.
hearing aid batteries for a sec, guys.
Oh.
Not my hearing aid batteries, the
Navigator.
headset.
No, biggest dog. It's not navigators minutes. It's minutes of hour. Get it right. We've got seconds of minutes and minutes of hour and hours of day.
Right when I needed the headset, it starts beeping on me. Right, now, where was I?
I think it's about done.
Oh, okay. I knew we were either coming or going, one of the two.
I think we're trying to go.
Oh, okay, go. Yeah, okay.
So yeah, good luck,
Doggers,
Peanuts.
Fondle,
Oh, we ain't
Turtle.
got the bit. Sorry, we've got to do that bit, haven't we?
Yes, Stewie, Brian, Timbo, Turtle. How many subs you got now, Timbo? Quick, sub to Timbo before we go. I want to see how many subs Timbo's got. We're doing a sub drive for Timbo today because they only had one sub, and I was their second sub.
I was his third.
So you can just right click on your whatever you call it on the left on the next to their name and go to their channel. And get a sub. Oh, 5. Okay, you're getting there.
No, he hasn't. He's got 6.
Oh, okay.
Well, I just clicked on it. It says 6.
Okay, Timbo said 5. Well, it hadn't updated then. Who else was out there? Fondle. I said Brian, didn't I? Zevlon. Brian. Astro Rex. Stewie, Dart. I know Carl was out there earlier. I don't know if I see Dora. Did anyone see Dora?
No, I don't think so.
Colin was out there.
Yes.
Farmer's Boy was out there.
I should hope so too.
Larry DeMarch was out there. Oh, TT guy was there earlier for the quiz. Fred Bailey. Yes. And there was a big Blue out there. That name sounds familiar.
Before he was here.
No, that there. Oh, they got
technology.
They got a spanner anyway. As long as they subbed, that's the main thing.
Oh yeah, you're subbed.
I have to check me subs to see if I'm.
No wait, I'm subbed.
Yeah, Judy was out there earlier, a long time ago.
I see Judy.
Yeah. Oh, I've got to come back all the way back down again. Biggest doggers. Yeah. That's everyone. No Carl, no Dora. No, Carl was there earlier. But I don't think Dora was. I'm up to 537 subs, so I'm on the good side of 500 now. Just me subs have just gone a little bit slow lately for some reason. I don't know why. We'll have to do something about that, hey Farmer?
Yes.
Yeah, mine too.
You've got enough subs. What are you worried about?
I'm not.
Oh.
I'm not.
We're contemplating an opening. Oh, what did you do with it? Blue. I don't know if you heard. Did you hear the music I was playing before, Blue? Didn't hear that.
No.
Where'd it go? I hid it somewhere. Is that it there? back to the beginning. Kevin McLeod. Monkey spinning monkeys. Yeah, I'd like to listen to some other tunes for the opening, for the timer, just to be different. But then we need something to finish off with. So this is okay to finish off with. I'll just put it down low. Oh, thanks, panel. Thanks, Peanuts.
Thanks, Terry.
And
Been a pleasure.
We'll see you on the other day. That's after Friday and before Sunday. No, it will be Sunday by the time we finish on that day. Okay. Night panel. Night Peanuts.
Night Peanuts.
All Blues on 7.41k.
Bye, everybody.
Night. Any words of wisdom?
No.
No.
Yeah, when I say how stupid can you be, it's not a challenge. That's a question.